Bet you all figured that when the music faded, we were going to start, right? Like about 30 seconds ago. Then the music came back. That was entirely on purpose because we want your excitement to ramp up even more. Like all those people sharing their location in chat. Perfect, thank you. Let us know where you're from because global events, global audience, I love seeing where everyone is hailing from right now. If you're new here, welcome. This is HashiTalks Deploy. HashiTalks are a global, themed, and regional live stream of events organized by our community team at HashiCorp. Our goal here is to support our practitioners around the world and amplify voices within the community. The things, the stories, the learnings you earned over the past year, over the past month, and we'd like to highlight these. Today for Deploy, we're focusing on deployment strategies, deployment tactics, because let's be honest, you can plan a full strategy. Sometimes you still need to be very tactical about it. It is what it is, and we'll make that happen, right? But as much fun as this is going to be, this is still a professional event, so quick house rules. If you have questions or comments, please let us know in the chat. We're live on LinkedIn, we're live on YouTube. We'll bring up the questions and ask them to our speakers or answer them directly. But of course, as you do so, keep in mind that other people are reading as well, so be welcoming, inclusive, friendly, and of course patient. Sometimes we can't get to a question right away. We'll do our best to answer everything. So it helps us if you're considerate and respectful. And of course, we have a much longer version of these guidelines on hashicorp.com/community-guidelines. If you run into anything that makes you feel uncomfortable in the chat, please let us know. We've got our moderator team on standby, Alexandra and Jasmine. They'll be monitoring the chat, so if there's anything, let us know. We'll take care of it. Hasn't happened yet. Today's not really a great day for that to be, something that we start on, so if y'all could help me, that would be so much easier. There's way too much work in having to handle those bad moments. Nobody wants those. So with that, I think it's time to get started with the event. Let me introduce myself first. My name is Karim Satirli. I'm a senior developer advocate at HashiCorp, where I focus on Nomad, Terraform, Packer, Vagrant, and just making fun things work. So I'm super excited to have an awesome schedule for today. We had a really, really great schedule for yesterday as well. If you missed out on that, there's two options you have. One, you could charge up your flux capacitor if you have access to one. If not, we'll have everything on YouTube. You can watch it live. There's a lot of great content. It is worth taking the time, especially over the next few weeks, if you have less things to do at the office or in your home office, and just re-watching some of the stuff that happened. We talked about making Nomad jobs more simple. We talked about, of course, Kubernetes stuff, building test environments on the fly. Too much to summarize in a single sentence. Good stuff. But today, we're going to be talking about something that I'm personally very excited about. Rotem is going to talk about database migrations and making things more joyful, which is very important because database migrations never are joyful. I know at least 5 people in the audience have probably used shmeek.sh, the shell migration script, and not been excited about it. And I get that. There's a better way. So with that, over to you, Rotem.
Hi everyone, my name is Rotem and this is my talk, Avoid Toll Roads, Deploying Declarative Database Schema Changes. So a bit about myself, I'm the CTO and co-founder at a company called Ariga. As part of my job, I'm the maintainer of 2 fairly large open source projects. One of them is called Ent. Ent is a Linux Foundation-backed entity framework for Go, and Atlas, which will be the primary topic of our talk today. So Atlas lets you manage your database schema as code. We open sourced it in 2021. It's used by thousands of projects on GitHub, and it has been sometimes called a Terraform, but for databases. And I hope that by the end of this talk, you will understand why. Okay, let's begin our story by presenting our hero, which is your database. So a few fun facts about our hero. First is that every application has one. If you're writing a backend application, chances are you have some database backing it. Your database contains the application state. Containers and application versions come and go, but your database is the one stateful component that contains the application data. The database always has a schema, even if you're using a NoSQL database. That's debatable, but we're focusing on relational databases today. Your database has some schema that reflects your application data model. If you're building an e-commerce application, this data model has things like products and categories and invoices. And these models are reflected in the database tables and columns. Number 4, as your application evolves, so must your database schema. When you add new features, you add new entities, you create new relations between them. These changes must be somehow reflected in the database schema, so this information can be stored and persisted and presented to users. And number 5, if you mess up evolving your database, you're in big trouble. Sure, you can throw away your production database and start up from scratch, but your CEO will most likely not be very pleased. When Ariel, my co-founder, and I started working on Atlas, the modern database schema management solution, we noticed this gap, even a disconnect between all of the modern things that we had with infrastructure as code and modern DevOps tools and the state of the art of whatever was available for managing our databases. Evolutionary database design, published May 2016 by ThoughtWorks, is still considered by many the seminal piece that defines the industry best practices when it comes to managing database schemas. When presenting the topic, I want to go over some important parts that define the current state of the affairs before we start to question them and see if we have better alternatives. At the time this paper was written, it was still a very common practice to manage database schema changes manually, kind of outside of the deployment and automation pipelines that organizations started to develop. This is, of course, completely out of line with the whole DevOps philosophy of automating things and building CI/CD pipeline. And so this article prescribes that we represent every change to the database as a migration script. This script needs to be version controlled together with the application code changes. Now, having our code repo as a single source of truth for the application is great, and storing the changes to the databases SQL scripts in our repo is a huge improvement, but that is still not enough for building automated pipelines. We need a few more things. One is that each migration needs a unique identification, basically a version number. We need to track which migrations have been applied to the target database so we don't try to create the same table twice. And very importantly, we need to manage the sequencing, the order in which these migrations are applied. Databases, being stateful creatures, require us to first create the column before we create an index on it. It doesn't make sense to create an index on a column that does not exist yet. Therefore, the sequence, the order really matters. Now, to solve this problem, many tools were created. There are hundreds of migration tools out there today. Some of them are ORM specific. They come with your application framework. Some of them are language and framework agnostic, like Atlas, but all of them work in a very similar way. Everything starts with you defining your migrations in something called a migration directory. Each file has a version number. Very commonly, we use a timestamp because times increase, and so newer scripts will have a higher version number. After that, we need a migration tool. We need some tool to manage to apply these migrations to the target database. The way the tool does this is when it's applied, it reads the migration directory, it connects to the target database, and reads something that is called the changelog table. This is a metadata table that stores information about which migrations have already been applied. Once it has that information, it can determine if new scripts need to be run on the target database. And finally, at the end of execution, the metadata table, the changelog table, is updated again to reflect the current state of the database. As I mentioned before, when we started working on Atlas, we noticed this huge gap in the world of schema management. On one hand, we had tools that delivered experiences like Terraform and Kubernetes. And on the other hand, we had all of these migration tools that operated in a very different way. Now, when you think about it, the gap or the difference really boils down to a different paradigm. Declarative versus imperative resource management. If we think about migration tools, they follow an imperative mindset, meaning we provide the tool a plan, a set of SQL commands to run on the target database. The tool's only responsibility is to inspect the changelog table, look at what scripts need to be run, apply them on the database, and update the changelog table. With declarative tools, tools have much more responsibilities. For example, with Terraform, we provide the tool the desired state, what we want reality to look like. The tool's responsibility is to inspect reality, to inspect our production system, for example, our AWS account, to calculate the diff. What is the difference between the desired and the current state? To turn that diff into an execution plan, and finally to run it to reconcile the difference. Okay, so which approach is better? Let's try to answer with a metaphor. So, my current state is that I'm in the comfort of the Ariga office, but my real desired state is to be some 4 kilometers west from here at Banana Beach. So the way to reconcile this is by driving there. If you started driving before navigation software was available, you will totally get the following example. So using navigation software like Waze or Google Maps is like the declarative approach, right? I have my current state, I have my desired state, I feed this into a tool, the tool inspects reality, traffic condition, the map, the different streets, and the tool comes up with a plan. Whereas the imperative approach is like when my dad used to prepare a handwritten note for me with instructions how to get from point A to point B, which he calculated using his map book. So head west to the street, turn right on that one, after 200 meters, turn left, and so on. So I ask you again, which approach is better? We built Atlas on the declarative model, so obviously we have an opinion here. I want to list some of the benefits of using a declarative model. So first of all, if it's not obvious from the example, there is way lower mental overhead when you let a tool do the work of planning for you. It's just easier. Because it's easier, it's also faster, right? I don't need to open a map book to look at the streets, to listen to the radio, to think about traffic condition, about different hours of the day. It takes less time to use an automated tool for planning than to do it by hand. And next point really depends, but assuming that the automation tool, the automated tool was written by domain experts, their domain expertise can be codified and turned into software so that everybody can enjoy their knowledge and industry best practices. Finally, because the declarative model offers a closed control loop, meaning it's connected to reality, the plan that will be output from the difference between the current and desired state depends on reality. For example, traffic condition, any road construction work will inform the result of a declarative calculation. Whereas if the plan is pre-computed, it might not be relevant and it might even lead us to a broken state. With the introductions behind us, let's now show a quick demo of what declarative database schema management looks like in practice. Now, Atlas can be run in many different ways. It's a standalone tool, it's a Kubernetes operator, but since we are today in a HashiCorp event, I thought it would be appropriate that we present the Terraform provider. So let's look at this very simple Terraform module. We have installed the Atlas provider. This is a provider that lets us manage database schema as part of our infrastructure as code setup. We are using a local SQLite database just to simplify things. In practice, you would be running against a MySQL or a Postgres database, something running on your RDS, but we are also seeing teams actually using SQLite for production applications. The next block is a data source that loads the desired state of the database from a SQL file. You can see that this simple create table statement represents the desired state of the database. Now, we can use many different ways to define the desired state of the database. We can use plain SQL, we can use Atlas BDL, which is an HCL based language, configuration language for defining database schemas. We can pull the desired state directly from your application framework or ORM. But for simplicity, let's just focus on defining the schema in SQL VDL statements Next, we define a resource that binds between the database that we are managing and the desired state of the database. Let's first delete this existing SQLite file just to reset things for our demo. And now we can run Terraform fly. Now, Terraform will calculate the difference between an empty database and the desired state. And you can see that it prints both an HCL representation and the create table statement that it's going to run this target database. Everything ran fine. And so when we run Terraform apply, we can see that no changes need to be made. Now let's see what happens when we add a C3, another column to our database. We can run Terraform apply and see that now Atlas wants to run alter table to add this column to our database. Again, if we rerun this thing, the state is already synced, so no changes to be made. So let's just recap how declarative schema migrations actually work. When Atlas runs with the schema apply command, or what you just saw as the Terraform provider, it starts with the desired schema. This desired schema is provided by something called schema loaders. Atlas comes pre-packed with a bunch of these that allow you to load the desired state of your database in a bunch of ways. It can be a connection to a running database that already has your desired schema. It can be a SQL file like we've shown, and it can also be code from your ORM directly read into Atlas. Once we have the desired schema, we connect to the database and we inspect it. Basically, Atlas runs a bunch of queries against the database information schema to build a representation of the current schema of the database. Once we have a current state and a desired state, we can calculate a diff. The diff basically is the delta, the difference between the two states. Now, this is not yet enough to execute because, as we mentioned before, the order in which Atlas is going to run these commands against your database really, really matters. So Atlas employs a bunch of algorithms like topological sort to get all the dependencies in the correct order and finally apply them to the target database. Sounds great, right? Well, as we were working on initial versions of Atlas, we had kind of silently open sourced it. It wasn't really ready for release, but then something happened, and that was that we accidentally hit the front page of Hacker News. Now, if you've ever been on this site, you know people there are very enthusiastic about software engineering, and they have very strong opinions. Some of the feedback we received was really, really positive, and we got our share of harsh criticism. I want to share with you one bit that particularly influenced us. And here it goes. So Redact 207 says, I'll never be comfortable with any tool that automatically generates schema changes, as I'm just never sure at what point it decides to delete parts of my production database. Now, this to me is scary stuff. And I don't know who you are, Redact 207, maybe you're watching this conference today with us. We take these safety issues of managing production databases very seriously. And from this point on, in this talk, it's going to be all about how we can preserve the benefits of the declarative model while avoiding the risks and the dangers that comes with managing someone's database automatically. So how do we do that? Let's see. Let's continue with our navigation metaphor. So in Israel, we have a very famous road called Road 6. Road 6 is a very fast road. It's well maintained. It's a highway that crosses the country from north to south. When you're planning a trip, you might want or not want to drive on it, depending on your budget, depending on your schedule. And for this reason, navigation software lets you make choices to define policies of how to get from point A to point B. Declarative workflows work amazingly well for stateless resources. With stateless resources, it does not matter. You can throw everything out, spin it back up fresh, and it will still work. With your database, it's not so simple. Going from point A to point B, sometimes there are multiple ways to do it. Some of them involve locking a table. Some of them involve breaking the contract between your backend application and your database. Some of them involve losing data. So if we want to adopt a declarative workflow for managing our database, we need strategies to mitigate these risks while maintaining all the benefits of a declarative API. How do we do something like avoid toll roads that navigation software does for database management? Let's see. The first strategy I want to present is something that we call automatic migration planning. In this workflow, we take the good part of declarative schema management, which is we have a desired state and we have Atlas to automatically plan the migrations. But the output is just a classic migration directory that we can commit to our Git repository, we can review in code review, and we can even run some automation, as we'll show, to verify that changes are safe. So many teams still want to keep the version migration flow, but they want to enjoy the good part of automatic migration planning. The next demo will show how Atlas can be used to automatically maintain your the migration directory of your application for you. Let's see how this works in practice. So like before, the desired state of our database is described in this file, schema.sql. But what we're going to do now is we're going to use an Atlas migrate command to calculate the diff whenever we change the schema. So initially, we don't have a migration directory, and Atlas will just write this initial migration to bootstrap the project. But now, whenever we modify the desired state, for example, we create another column, we can generate a new migration. If we want, for example, to create a new table, create table T2, we can rerun the command to generate a new migration file. Of course, if we have no changes, Atlas will detect this and tell us that no changes are to be made. Now, the advantage of this approach is that we can now add these migration files, these automatically generated migration files, to our pull requests, to have them code reviewed, to have them checked into source control. So a team has ultimate control exactly what SQL commands are going to be run on the production database. If these files are added to pull requests and reviewed by humans, then of course it's possible to catch dangerous things like accidentally introducing destructive changes. But wouldn't it be great if we could just integrate this as a check in our CI pipeline? Wouldn't it be great if Atlas could do the migration reviews for us? Well, Atlas had another command called Atlas migrate lint, which can be used exactly for this. So let's now do something. Let's plan a destructive change. So let's drop our T2 table. We get this fourth migration that does drop table. And now let's show how we can use Atlas migrate lint to check the latest change. We can see that this file, this new file that we just created, contains a destructive change. Now, this tool can be integrated into your CI pipeline to prevent pull requests from landing that accidentally contain dangerous changes. You can see here by this red X that the status code of this command is not 0, meaning in a CI job, it would fail. But what if we want to stay within the bounds of a real declarative workflow? Well, the next strategy is called diff policies. And this is how it works. Diff policies modify the generated execution plans based on user-defined policies. For example, a diff policy can tell Atlas to always create an index concurrently or to never drop a table. This has the benefits of avoiding the types of changes we don't want in our system, for example, to enforce that we only perform additive changes or that we never create foreign keys because that doesn't work in our system. Let's see how this works. One of the top concerns when it comes to declarative migrations comes from experienced Postgres users. And these users asked us about how can they control index creation when creating new indexes. So let's show this with an example. We have our Terraform module here. Here's the data source that's loading the Postgres.sql file, and here's the resource that controls the actual database schema. So here we have a simple table to create. We can see that we can create the table. Rerunning Terraform shows us that the schema is already in sync. Now, what happens if we want to create an index? Specifically, let's add a unique index on the username column. So we can see that the plan generated by Atlas is create unique index, which means that this will be a blocking operation. Postgres will wait for the index to be rebuilt before releasing this command. This will be a table lock. The table will be locked for writes, and that's not great when you're doing this in production. So to control this, as we said, Atlas supports something called diff policies. Let's show how this works. So we're going to define a diff policy. We have a policy for concurrent index creation, and we're going to say create true, meaning this is going to instruct Atlas to build this index concurrently to make this an asynchronous non-blocking operation. In addition, we're going to need to tell Atlas to not run this in a transaction because you cannot run concurrent index creation in a transaction. So once we do this, our index is created concurrently. Our next invocation is already sync. So there you have it, avoid toll roads, the database edition. The last strategy that I want to share today is something that we call interactive declarative migrations. This is very new for Atlas. In fact, it's so new that it's not yet implemented in the Terraform provider. So we're going to see a demo with the CLI only. And it's very similar to normal declarative migrations, except in certain thresholds, Atlas will open up your browser with a UI that shows you the migration plan, safety checks that run against this plan, and an inline editor so you can modify the plan if you want. It's not always convenient to have the UI pop up every time that you want to make a change, so you can control in what thresholds Atlas will ask your review. The benefits of this approach, of course, are to avoid unwanted side effects while preserving automatic migration planning and all the benefits of declarative migrations. And it allows you to keep a human in the loop for the edge cases. So you can define policies that most of the time will not ask for your permission for the normal and known cases, but in the edge cases to still have a human review. Let's see how this works. So we have our desired schema here, the Postgres SQL file. I'm going to run Atlas schema apply. And notice that we have three options: apply, lint and edit, and abort. Let's pick lint and apply. This will open our browser. You can see that our migration plan is here. We see that Atlas analyzed the changes and didn't find any issues. And we also have this ERD of representing the change. Let's approve this. Now, we can see the migration logs that ran against the database. Let's go back and make some change. Now let's do a change that is dangerous. It's a destructive change, dropping a column. Again, let's run lint and edit. And you will now see our drop column clause, and you see the change analysis. This is a destructive change, dropping non-virtual column username. And you can see this in the visualization. So let's skip this change. Now, we mentioned that we can control when Atlas asks for our review. So the way to do that is using a lint review error. For example, lint review error means, or let's pick warning. Lint review warning means Atlas will only ask for approval in cases that it finds some diagnostics. So if schema is synced, so we don't need approval, let's make an additive change. This also doesn't need approval since it's completely safe. Changes auto-approved based on lint review policy. But if we were to add a unique constraint, you will see that the changes do require a review. Why? Because these are data-dependent changes. One, it's a non-concurrent index that's going to be created, and adding a unique constraint on an existing column might also fail. In this case, we want to go ahead, so let's approve and see that Atlas successfully ran our migration. Okay, wrapping up. What did we discuss today? We started off by demonstrating the declarative approach for database schema management. We then discussed some of the risks that might deter us from adopting this approach to our production system. And we followed that up with 3 different strategies that allow us to mitigate some of these risks, such as automatic migration planning that lets us review changes during code review and in CI before they're applied. We mentioned diff policies that feed Atlas with considerations and constraints when it is calculating a plan to prevent unwanted side effects to a database. And finally, we demoed interactive declarative migrations, which kind of bake safety policies and human in the loop on edge cases into the declarative migration workflow. Thanks for watching. I hope you enjoy the rest of the conference. And if you have any questions, feel free to ping me on Twitter. Have a good day.
Hey there, Kareem. You are muted. Hey, folks. Looks like we might be having a little bit of a technical issue. We will be right back with Kareem.
Techno music would have been nice. But alas, the reason we don't deploy on Fridays is because we usually screw up on Thursdays. Thank you, Chris. There we go. Please read this in your best German dialect, so this makes more sense. So, since we missed out on all the good parts, I'm just going to start again because we can cut all of this, the magic of editing. When Rotem showed me this one for the first time, Atlas, amazing tool. Half a year ago, I think I looked there and I was like, so much easier than we thought it was going to be. Anytime you read any book on database migrations, the chapter usually starts with, this is an advanced topic, watch out, here be dragons. And not the cool Dungeons and Dragons kind, it's a sad kind. We don't want that. And things get a lot easier when you have a tool that just works. Personally, also a very huge fan that it's written in a way that I can just use HCL and have Terraform generate part of my files. So with that, while the chat was going on, while the talk was going on, I saw a couple of great questions, so let me highlight two of them. And we'll start with one on AWS and Azure. So what is the best way to convert AWS IAC infrastructure code to Azure IAC? The best way for this, I'm just going to answer this for you, is don't convert it in a technological sense. Don't use a tool that just translates one service to another, because what you'll get is a non-optimal utilization of services. You'll get, in the case of EC2 instances, converted to Azure virtual machines. Are we talking Linux? Are we talking Windows? How are you doing storage? How are you doing CPU allocation? What's the end goal? The best way for this is really to take a step back, trying to figure out what worked in your infrastructure, what didn't, and to build it with that knowledge. There are tools like Terraformer that can convert some parts, but really the best way is to just start from scratch. That's not the quickest way, but it will definitely get you a better end result. And then we had another question from Shantanu. And so you're right, Nomad 1.7 is out. And today, HashiTalks deployed, day 2 is going on. And if you paid attention to our schedule, we had a slot there that said TBD. We should have called it redacted, because that's what we usually do with HashiConf, because we didn't want to spoil the fun. But yes, we're going to be talking about Nomad 1.7 on stream in just a little while. We'll have somebody from the Nomad team talking about some of the cool new changes that are in 1.7. And that's going to be super, super exciting. I'm very excited for the content that we are going to show, and you'll get to enjoy it as well. Wait with updating until then, so you know what you're in for. Before that, though, we've got Michael Greenlaw, who's going to talk about FedRAMP and dealing with public sector and all the fun challenges that come with that. Quick note, if you're using Terraform in AWS GovCloud or any of the sovereign clouds offerings, let us know. We love to hear what you're running into. We have our team, the Terraform provider team, the AWS Terraform provider team, working on that as well, of course. But not all of us have access to all the environments. So if you run into issues, help us help you. And with that, we're going to switch to Michael.
Hi, I hope everyone is having a great day and that the HashiTalks are going well. I am Michael, and I'm going to be talking a little bit about FedRAMP today. So, with that being said, what is FedRAMP? FedRAMP is the Federal Risk and Authorization Management Program. It is a standardized government-wide program. It's designed to empower agencies to use modern cloud technologies through federal marketplace. You might be wondering, why do we need this? Well, before we had FedRAMP, all of the different agencies had different programs to go through. Therefore, it was really hard for one company to sell their product, cloud-based product, to multiple different agencies. It was a lot of hoops to go through. So to make it easier, we have FedRAMP, right? And so to list a cloud product or service on the federal marketplace, an authority to operate must be attained first. And so a lot of the times you're going to find that when doing FedRAMP, why would we go through the process of updating a current architecture? Like, you have a commercial product, you're in the cloud, and you want to sell this to the government workplace, but now you have to take everything you already have on the commercial side and update it to make sure that it's compliant, right? So when I do this, when we can, why go through this process of updating the current architecture when we only need resources and the authorization boundary to be compliant, right? So not to mention there's less clutter, less separation boundaries, and easier maintenance after we achieve an ATO. So I've mentioned ATO a few times here. Let's take a look real quick at what an ATO is. Is an authority to operate. Something we have to talk about after getting an authority to operate is continuous monitoring, and how do we get started in the whole process. And so, like I said before, after being issued the ATO, the process of continuous monitoring begins. You have gone through the process, you have been audited, and now, all right, you have an ATO, but you can't slack. You can't get lazy and let changes slip through that are going to let you or remove you from being compliant. So, in our experience, rewriting an established service or product is quite a lengthy process. Thus, we find ourselves working in new cloud provider accounts often. And when doing this, we're starting from zero. So we realized that to speed this up, we needed a starting point, something we could standardize, which in this case, a landing zone, and it would help us streamline this process of going from no account to deploying workloads in a federally compliant environment. And so with that, let's talk a little bit about AWS landing zones. A landing zone is a well-architected multi-account AWS environment that is scalable and secure. Right, and like I said, it's very important for us because it's a starting point to quickly launch applications and deploy workloads. Because, as I mentioned earlier, we are starting from a greenfield environment quite often. Next thing is we want this to be secure and compliant. Talk a little bit about the SRA in a moment to kind of go over that secure aspect. And then, like I said, it's a FedRAMP. It's FedRAMP, NIST, PCI compliant. And if we're going to be able to do all of these things, we want our landing zone to have that off the rip instead of having to go back and fix things later. There's a plethora of options for AWS landing zones. We have the landing zone accelerator. We have control tower just by itself doing a lot of click ops, or we have AFC, which is the CloudFormation version of AFT. A few more options I have not listed. Another thing is that AFT is it can be AWS native, and it provides a pipeline for deploying and maintaining infrastructure as code. And another great plus is that it is relatively low priced. As mentioned earlier, it does use control tower on the inside. So if you're looking at using control tower, you want to go a little bit further, I highly recommend AFT. And with that, this talk is going to be how to go from AFT to ATO. It'll be achieving AWS native FedRAMP through Terraform. All right, and I am Michael Greenlaw. I'm a co-founder and senior consultant at Hanabyte. And if you want to reach out to me, you can contact me at michael@hanabyte.com, or you can reach out to me on LinkedIn. I love to talk about this stuff, so please feel free to reach out. Don't hesitate. Let's have a chat. All right. AWS AFT. All right. So AFT sets up a Terraform pipeline to help provision and customize accounts control tower. Gives the advantage of Terraform-based account provisioning while allowing us to govern our accounts with the control tower. It also supports Terraform Cloud, Terraform Enterprise, and Terraform Open Source. It does use a GitOps model so that when we apply changes or want to create an account, it automatically recognizes those, pulls those in, and creates the account for us. It also works or integrates with tools like GitHub, GitLab, Bitbucket, etc. So let's check out the AFT workflow. First, we have a new account request, right? This would be something I would initiate. And what I would do is I have an AFT account request repository. I go in, I make a change to the code and say, I would like to track a new account. This is recognized once again through the GitOps module. And there we have the account request pipeline. So the pipeline kicks off after we push the code up, and then it adds in some information into a DynamoDB database, and then the request trigger function kicks off. So this is a control tower update. For example, adding a new account, right? It would say, yes, this is a CT update, and we would move on to the account request queue. This then moves to the account request processor, and we are thrown into the control tower management loop where we have a account being issued or an account being vended, if you will, and then it kicks off into the account provisioning invoker. So there's another flow to this, however. Right? Like once we have created this new account request, we also need a way to invoke customizations on the account, right? Because the AFT gives us that capability to create or add customizations to our account. So if you see towards the bottom, we have an invoke customizations request. What happens here is I add code to either a global or account customizations level repository, and then I invoke a state machine that kicks off the loop we see at the bottom. And in turn, the state machine kicks off pipelines Pipelines then make changes to our accounts, and that is how AFT works in a nutshell. I also mentioned the AWS SRA earlier, or the Security Reference Architecture. We use the AWS SRA as a guideline. It's been described as a holistic set of guidelines for deploying the full complement of AWS security services in a multi-account environment. There's a quote directly from AWS. The good news here is that we can use AFT and still adhere to the SRA. While it'll be our own version, that is still built off of that SRA. And like I said, it just fits perfectly with everything. So it's quite a nice tool to use when it has all this stuff built in. Next, let's start with Control Tower. So to get this kicked off, it's not just plug and play with Terraform. We do have to create a few accounts first. Obviously, you're going to want your payer or management account. And what we do after we have that is we need to agree into Control Tower, and we need to create a security OU and an infrastructure OU. There will be a audit and logging account in the security OU. Those are created by default when setting up a landing zone with Control Tower. And then we will add an AFT management account, not to be confused with the payer management account, an AFT management account in the infrastructure or infra OU. As you can see there, we have on the right-hand side, the foundational OU is security. That is going to be pre-populated, and then I added in the infrastructure or infra OU towards the bottom. And over here, we're going to have to add another account, right? Like you can see, we're adding in a log archive and an audit account. But the problem here is that we're missing one, right? We need 4 accounts, and one of them would be the AFT management account, like I said. And so what we do is we go to Account Factory, and then we create the AFT management account under the previously created infrastructure OU. And once this process is complete, we can start preparing for AFT deployment. All right, so AFT preparation and apply. So our first order of business is to store the state of AFT in the payer account, right? Like it's going to track all of the stuff that AFT is setting up, the code repositories, let's see, the code pipelines, use state machines, and things like that. So it has to be run from the payer account. In this case, I prefer to just create buckets by hand. I start off with a basic bucket, and then I add my policies in. I have created a pretty basic policy on the right-hand side with just the delete, get, list bucket, put object. This will work. And if you want to make it a little bit more secure, feel free, go ahead and edit as you will. But yeah, this should work. A little copy and paste there will get you on your way. Now, time for takeoff. So our first part of the module is the source. As we all know, this is going to pull from GitHub, and it's going to pull that specific version of the code that we want. So as you can see, we created those 4 Control Tower accounts, right? I've removed the account numbers, but you can see the Control Tower management account ID. You can see the log archive account ID, the audit account ID, and the AFT management account ID arguments. We will need all 4 of those. They are required. And we also need a home region and a secondary region. So what we're going to have to do here is go over through AWS and get our account numbers, populate that in. And then our next step here, we have some optional parameters. When I say optional, these can get kind of in depth. There's a lot more information on this on the GitHub page that you can find at AWS-IA. The optional parameters for me are OSS. I was trying to do this as cheaply as possible. It is an example, right? And then we also wanted to use code commit as our VCS provider. And then last but not least, there's quite a few optional feature flags. So once again, you will have to go through and look at all the feature flags you want to use. Just note really quickly that if you are using GovCloud, you will have trouble with the AFT VPC endpoints and a few other things, but mainly in this case, there's a line, things like line 234 in a data.tf file somewhere that has an endpoint that doesn't work. So that's going to cause a little bit of an issue for you if you're in GovCloud. But yeah, so with that, you can apply this. This is going to create over 300 resources, and it can take quite some time. So someone say enough time for a coffee break, if you will. And now we're moving on to the account request section. So we have the 3 C's: code commit, code pipeline, and cloning. What happens when AFT runs is that it creates 4 repositories. There's the AFT account request, the AFT account customizations, the AFT account provisioning customizations, and the AFT global customizations. The first thing we want to focus on, however, is the account request customizations, right? The account request, just the account request, followed by provisioning. And finally, we work with the global and account customizations. Next, we have code pipeline. AFT creates 2 pipelines. At first, it'll be the CT-AFT account request and the CFT account provisioning customizations. These 2 pipelines use a GitOps model, as mentioned earlier. And once code is added to either once code is added to either code commit repo, the pipeline kicks off and runs. And last but not least, we have cloning. All of the code commit repos are empty to start. Right, so we're gonna have to clone them down and add code that has been pre-provided by AWS or HashiCorp if you look at any of the tutorials. So what I do in this case is I clone down the code commit repository using git remote code commit, and then I'll create a temp folder. I go into the temp folder and I copy down the resources from AWS or HashiCorp, and then I remove the example folder and copy that code into the temp code into the code commit repo so that it has all that we need. Like I said, I remove the example folder and then I create a main.tf file in the Terraform subfolder. All right, and as you can see here on the left-hand side, this is what my AFT account request looks like. We have the Terraform folder, and then we have modules. That is correct. Leave the modules there. It will reference that in the code coming up. And we have a backend.jinja file that you'll need to edit. I believe I mentioned that too as well, but there's our main.tf. Right, and this code has simply been copied over, as you can see, from GitHub on the right side, right middle. And I've removed that examples folder that I mentioned in the previous slide. All right, so let's make the accounts. All right, and so as we can see here, our source pulls from the modules folder at the TF root. Like I said, we want to leave that modules folder because it is absolutely necessary. And then next, we add in the control tower parameters so that AFT can use control tower to provision and maintain our new account. You'll notice if you use control tower, these are a lot of the same things that you use to initially create your account. So that shouldn't be too abnormal. It should be quite familiar. Right? And then we add account tags and management parameters as necessary. I've kind of left mine pretty basic example things. I'll let you fill those in as you like. Then one thing I want to say is to take note of the account customizations name value or argument, if you will, at the very bottom of the page. This needs to match the folder we'll be using later in our AFT account customizations repo. So yeah, it's a big one there. If anything messes up while you're doing this, feel free to look back at this and see maybe the folder name is not the same. Another thing, I believe I did mention the backend.jinja file. Once again, I think that should be coming up in a moment here. We'll need to change the required version that the backend.jinja fills in. As of a recent update, it seems to error out, so we'll have to specify that version. And I will say, you've seen here, I've added in a shared account, right? You can also add in your AFT management account. You can add in maybe like a transit account for networking. You can track your other accounts as well, the audit and logging. All of those work. All you have to do is push up or copy this, add in the correct information, change the module name, and push it up, and it will go through the process of adding those into the pipeline workflow we saw earlier. And so next. One thing I wanted to say as well, you can see at the very bottom of the screen here, there's a CT AFT account request. That is the pipeline. It should look just like this after you've pushed your code up. It'll be in progress. All right, and yes. Back in Jinja, as you can see on line 6, we have specified the required version. This is using the TF_ version to plug that value in, but it's broken in a recent release. So this will most likely be fixed at your time of viewing, but for now, I just wanted to let everyone know and be aware that this creates a few problems for us. All right, now we're going to get into the meat and potatoes, customizations. So what are the types? As you noticed earlier, I mentioned a few pipelines and repos, one of those being provisioning customizations. And so AFT provides flexibility to customize the provisioning process for new accounts and integrate with systems prior to the account customization stage. But we won't be doing any provisioning customizations to start, right? This is only an example. So the only time we'll run this is to create our step functions. All right. And the next, we have global customizations, right? So these are used to customize all provisioned accounts with customer-defined resources, right? So what we're saying here is that each account created with AFT gets its own pipeline, right? And each pipeline has a global customization stage that references this code in the global customization repo. Thus, to apply globally, we make one change in that global repo, and then we run the pipelines for each account to make sure that change is applied. And last but not least, we have the account customizations. So this is used to customize any provisioned account with customer-defined resources, right? And so this is the third stage in each account pipeline, and it's to apply account-level customizations, meaning changes that only apply to that account, right? So if I wanted to apply a password policy to my global customizations, I would add that to the global. I would then run all my pipelines. However, if I only want to make a change to, say, our shared account, I would go into the shared folder, make a change in the account customizations, and then push that up and run the pipeline. So it only makes the change to the shared account. Let's see. Next thing we have, this is a bit confusing. It's the same process as before, right? As you can see in the GitHub picture towards the middle, we have the AFT account request folder, right? What we've done is we've already copied this over, right? We pulled the repo from AWS, and then we copied the code from AFT account request and then moved the files into that AWS repo, and we push it up so that our changes are made and pulled in with AFT. And so it's time to do that with the other 3 code commit repositories, right? So I clone each of the repositories from code commit. I'm going to make a temp folder. I'm going to go into that temp folder and then clone the AFT code from GitHub into there. And what I'm going to do next is move the files from that temp folder. You know, if I have, say, for example, the first repo I copy down is provisioning customizations from code commit, I would then move the files from the provisioning customizations in GitHub over to code commit, right? And don't forget, when doing all of these, the backend.jinja issue from earlier, that's going to happen with each one of these in this case. Like I said, it most likely will be fixed in the future, but as of right now, it's going to create a little bit of an issue. And, you know, then again, maybe I've done something wrong and I could be proven wrong. Like I said, reach out, let me know. I would love to talk about AFT. Yeah. And so before you push, I want to make a note here. You could technically push to the global or the account customizations really quickly, but the first thing I want to do is push to the account provisioning customizations repository in code commit, because we're going to kick off a pipeline that's going to create some step functions for us that will allow us to trigger the pipeline for our global and account level customizations. All right, so let's look at these state machines really quickly. Right, so if you haven't already, go ahead, push up your code for the AFT account provisioning customizations repo, and it's going to kick off the second pipeline. I think it's CT account provisioning customizations. And what's going to happen is it will create state machines. So after a few minutes of letting that run, you'll be able to go look at our state machines. You can check it out immediately. Notice that there's only, I think it's 2 or 3. And once we're done with that run of the pipeline, we should have 4, right? So pushing the provisioning code kicks off the account provisioning customization pipeline, which in turn creates the 4 machines shown to the right. The big one here for us is going to be the AFT invoke customization state machine. Like I said, it's what we'll use to cook off pipeline jobs using the format seen on the right. We don't want to run this now, but what you would do is you would go into AFT invoke customizations, and then you would do a new execution. And we have to use the code down here, kind of towards the bottom middle, that will target the account, and we have a target value of like just the account number. And so right along. Yeah, I've been told this talk is very technical and quite boring. So you know, we had to add Mr. Worldwide, you know, peak humor, right? So yeah, just spicing it up a little bit. But continuing on here, we'll use IAM account password policies as an example of how global customizations work. That's why I referenced it earlier, because that's how I'm going to be showing you how to do this. And so the first thing we're going to do is add an im.tf file to the AFT global customizations /Terraform folder. It should look just like in the photo. and then we're going to populate that file with the code seen on the right. And so this is just a basic IAM account password policy resource. It's pretty much the example resource, right? And then we have a few parameters we set ourselves. That's all that needs to be in here. There's nothing else to do for this. It will apply globally. Once you're done, go ahead and push those changes up. And next, we have the account customizations. All right, so what we're going to want to do is rename the AFT account customizations folder. There's going to be an account template subfolder in here that we want to change to be shared. We want to change to have the name shared. Why do we want to do that? Because of the argument we referenced earlier. When you're doing your AFT account request, we need AFT to know what folder it's going to be in. So if that was, say, for example, shared to, AFT wouldn't be able to find it. And that's the same reason. That's just like with account template. AFT is not going to be able to find it, and that's exactly why we changed it. And then I'm going to add a file called ebs.tf to the AFT account customizations /shared/Terraform folder. Just note we're going a little bit deeper than in the previous customizations folders with the shared/Terraform. And so what we're going to do first here is we're going to turn on EBS encryption by default, right? Very basic AWS resource. Note the data source at the top. I believe I'm going to be pulling that in one of my policies later. I'm not entirely sure it made it into this slide. And then we're going to create a KMS key, a pretty basic KMS key here. And we're going to be using this to encrypt our volumes, as you can see with the AWS EBS default KMS key example. And last but not least, like I said, we're going to create and attach a policy to the KMS key. You're not going to be able to see my policy here. It's quite long and quite frankly, I think we are all capable of creating this KMS policy. And I just don't want to include a slide with nothing but policy code on it. So once again, like I said, if you have trouble here, let me know. Don't hesitate to reach out. I will gladly share the policy I have. I've got example policies, and we will have a blog coming out soon with the second part of this that goes a bit more in depth than this presentation will. So yeah, a few examples to go off of there. Right. And so once that's done, we can push all of these changes, right? We push our global changes, and then we push our account customization changes. So yes, like I said, we push it, and then should note these changes won't automatically take effect until we've invoked the state machine, right, which we talked about earlier. So to invoke the customizations, we're going to run the AFT invoke customization state machine using the example code on the right. You want to ensure that your account number matches the account number of your shared account created in the infrastructure OU by AFT. So when you go ahead and you create that account using AFT, you're going to have to go back, pick out the account number, and make sure you bring it here, because if you don't use that, it'll trigger against a different account and it won't see the code. Nothing's going to happen. I might have a successful run. That's going to happen. And so your first run here is going to be a bit time consuming. You'll notice after a few minutes, the pipeline's running, it slowly starts to move. You can go into your state machine after you kick it off. You'll see a bunch of the different stages that it goes through, and it'll get stuck for a minute on I think it's the second or third stage. And once it goes through, it's creating your pipeline at this point, right? It has to create another pipeline for you specifically for that account. So it just takes a few minutes. And then after that, once you have your pipeline created, it's usually like 5-6 minutes for the pipeline to run each time. And once again, if you need a code example of how to start your execution, this is exactly how I would start my account if my account was that number. All right. So I'm going to go through a bit of a recap here. What we've done so far is we have created 4 accounts in Control Tower. And we then used AFT to build out a pipeline and add in more accounts, right? So we now have a shared account we have a shared account on top of our 4 initial accounts. That shared account had a pipeline run against it that applied a global customization, right, of a password policy. You can go into the console and see these changes for yourself. And then it has also added in, like I said, the EBS change. That is a encryption at rest control that is going to help you with compliance in a few different spaces that I'll talk about in a moment. But so yeah, we've gone from literally nothing, right? We started with a payer account, and we have now in a very short span of time spun up a entire landing zone where we're able to go through and deploy infrastructure as code, and we can begin using our Terraform pipelines to build out stuff like code pipelines and code build projects, right? And then begin deploying our workloads. Okay. That's it. Like I said, with that, we've successfully created a landing zone. We've implemented a control that satisfies multiple levels of compliance, right? Encryption at rest and EBS volumes satisfies a few things. You can feel free to look up the ones that are missing. But yeah, that's you're going from 0 to control and absolutely, or sorry, 0 to a FedRAMP control in absolutely no time. So using Terraform and AFT, we're able to expedite creation of a landing zone, implement controls, and use state to ensure our environments stay compliant, right? We can go back through, you got to remember, obtaining the ATO is not the only part of this process, right? We have to maintain, sorry, yeah. I don't know if I messed that up or not, but obtaining the ATO is not the only part of this process, right? We have to maintain the ATO through rigorous maintenance as time goes on. It's compliance is not something that we can rest on our laurels about. So yeah. And with that, I believe that ends this presentation. Once again, I am Michael Greenlaw. I am a co-founder and senior consultant at Hanabyte. Please feel free to reach out to me. Michael at Hanabyte is my email address. And once again, we have my LinkedIn down at the bottom. Yeah, just want to take a moment to say thank you for setting all this up. I really appreciate the opportunity to be here, and I hope everyone has a great rest of their day. Okay. Bye.
It's a tried and tested tradition that during one of the HashiTalks sessions, my mic fails. Usually it's once per event, but we always continuously try to outdo ourselves. So maybe it's going to be a second time this year. We'll find out. But there we go. It's beautiful. I think, as Michael said, compliance is not something we can ever rest on and just enjoy, because it just never works that way. And sometimes when things go wrong, you're going to need to have a good break glass procedure. And I'm very excited about Sebastian's talk about this, on how to build a break glass solution with Boundary, Vault, and a ServiceNow integration, and making sure it works. So with that, over to you, Sebastian.
Hi, my name is Sebastian Maniak, and I'm a SecDevOps engineer that focuses around network automation and security automation using tools like HashiCorp Terraform, Vault for secrets, and lately I've been doing a lot of work with Boundary and also creating self-service portals within ServiceNow. So I'm going to talk to you about how you can build a break glass solution with HashiCorp Boundary and Vault, and creating a self-service portal that allows your employees, your customers, your users to be able to enhance access to specific infrastructure. So what is a break glass? So breaking glass accounts are a type of privileged accounts that are used in emergencies, such as system failures or security breaches or access enhancements into secret infrastructures. And they should be managed in a way that ensures that they are only used when necessary and that they are audible and traceable. If we take a look at some of the best practices when building these accounts, we want things to have limited access. So only a small number of trusted individuals should have access to maybe that infrastructure or to that break glass accounts. And their access should be regularly viewed. We have to establish procedures, right? Establish a clear procedure for using a break glass account, including when it should be used, who can use it, and how it should be used. We got to monitor usage, monitor and audit the use of the account, including who has used it and when, and need to ensure any suspicious activity is really investigated. We need to secure the account. We need to make sure that the account is strong, its unique credentials, they get rotated. We need to ensure that it is protected with multi-factor authentication. We also want to make sure this is tested regularly. regularly testing the accounts to ensure that it is functioning correctly and that any issue are identified and resolved, right? Having incident response plan in place is very important. We have to have an incident response plan so that when that account is used, right, we need to include the procedures for restoring really those normal accounts or identifying that case of emergency itself, right? We need to have an expiration date when that account actually expires or that access expires, kind of having this just-in-time credentials or be able to deactivate it once it's no longer necessary itself. So when should we use these accounts? Well, break glass accounts or enhanced security accounts really is a method of providing a temporary access in emergencies where normal procedures are not suffice. It should only be used in the last resort, such as when, for example, a help desk or a system administrator is not available. And this method is often used in situations where there are accounts or authentications or authorization issues. And in certain companies, there may be critical tasks that need to be performed by individuals who are not normally authorized to do so. For example, a junior database admin may need to perform a certain task because of a specific criticality. And that senior database admin that has access is not available. So we need to have some type of break glass solution deployed. By having these break glass solutions is really implemented by a prepared emergency process that can be quickly accessed without any unnecessary administrative delays. And these accounts and procedures for accessing them should be well documented, tested as part of our implementation process. It should be managed carefully and ensure that timely access when needed itself. So when we take a look at this, these break glass requests, we have to have a flow. And this flow really starts with the initial request. So in this case, we're going to use ServiceNow as our main service catalog to request that. We need some type of approval. We need auditing, governance. We need change management approval, manager, director, senior, VP, etc., to approve those requests. We want to have dynamic credentials be sent and generated. So we want this just-in-time credentials. We don't want that user to have access to anything. We want it to be given to them without them seeing it. We want this access and provisioning in it. We want logging and auditing. And of course, we want this post-access reconciliation that everything goes back to normal, but we have logs and audits of everything. So if we take a look at this environment, it's pretty straightforward, kind of what I built. And it focuses on using ServiceNow as our self-service portal. So ServiceNow has a full self-service catalog that you've used probably throughout your career that you can get things done, get an image installed. But you could also use it to make changes and orchestrate flows or create an entire workflow for the system. So what I'm going to kind of demo is creating a self-service catalog request, which creates a rhythm that is sent to review to your manager for approval. Once that CTask is sent, it's approved, rejected, whatever the initial outcome is. Then ServiceNow and the mid servers make a call to our HCP boundary. And boundary is going to grant, or ServiceNow is going to make boundary grant us access for that specific user. Once that initial request is approved, then the user can then authenticate to boundary. They're going to connect to boundary. They're going to try to connect to Azure AD. So they're going to initiate that connection. They're going to redirect the auth to Azure AD, which is going to return that JWT token, which then Azure requests the user to authenticate and the user connects. Once that user connects to that specific device, for example, in the demo I'm going to show is we're going to connect to this EC2 instance. And inside this EC2 instance, we select inside of boundary, hey, I'm going to connect to this device. In that time, boundary makes a request to Vault. So Vault is our secrets engine. that stores and manages all our secrets, keys, APIs, passwords. And Vault is going to give us the key and is going to inject the credentials into our session. So as the user, I don't see the password, and that key is generated for me and injected into the worker for me to connect to. Once that happens, I am able to then SSH and establish a connection, which then I'm starting to record my SSH sessions, which are then being logged and audited for events. So we have a trail of what is happening on the device. And from that gives us this full auditing, logging, deployment in it. And then at the specific time of this, maybe an expiration, maybe a 30-minute, 1 hour, 5 hour cycle, whatever is been initiated or requested, ServiceNow is going to see that that time has expired, makes an initial call or workflow call to Boundary and revokes access for this. So now the user session is disabled, access is removed, and the entire environment is back to normal where it should be. And with that, we get audit logs from ServiceNow from a whole ticketing perspective that we can audit and see and have governance that somebody accessed this at this point in given time. And we also have these just-in-time credentials at the same time that were deleted, removed, that I don't need access to those devices itself. So it really helps us build this self-service portal that allows us to, get into specific private infrastructure and instances itself. And really the benefit of this is enhanced security and dynamic credentials, comprehensive auditability. We see everything that's happening. Governance through change management, which is super important, big enterprises. Flexibility for various organizational needs, right? We can apply this not only to EC2 instance inside of private networks, but Kubernetes environment, databases, networking devices. So it gives us a variety and flexibility of how we can actually demo and show this off. So let's take a look at the demo on how this works. The first thing we're going to do, everything is built with Terraform in mind. We have HCP boundary deployed. We have a worker deployed in here, so it creates that tunnel between the private worker and HCP boundary. We have specific targets here deployed, so a Linux server itself. And then from a boundary perspective, we have our boundary targets deployed in here, where we're injecting credentials from HashiCorp Vault. We have a bunch of other devices itself. We have our credential store deployed. We have our credential library. We have our authentication method with Azure, our OIDC. We have specific roles that have been defined for those specific teams itself. So if we open up the diagram here, we have our user, and here we have an environment. So we have an AWS region where we have a private worker deployed. This private worker has established an SSH or a mutual TLS tunnel between the HCP boundary worker. So all access inside this private subnet is only outbound access. There's no inbound access. So when the user requests it, Boundary is going to create that connection through that worker into that environment, into this EC2 instance. And if we opened up our ServiceNow portal, we'll see that we have a pretty basic ServiceNow portal just to see this in action. We kind of describe what we're happening is we're providing enhanced secret access or break glass solutions, where in this case, I'm the system administrator. I need access today, right now. I want access to the platform engineering team. I'm going to put a reason for it. Maybe it's a critical severity. I can give this a project code, CVE. Maybe I'm trying to fix some CVE of this device. So what happens in this instance is now we submit this request. This request is going to go towards an approval process. So we can see that in this demo, I'm the system administrator, but this could go to a team, a VP, directors, whoever it wants. Then that team is going to get access, or is going to get notification through email saying, hey, are you approving this request? This user wants request to the platform enhancement engineering team. And if we take a look at how our existing environment looks like in Boundary before we approve this, then this will kind of really help us understand it. So right now I have Boundary UI open, a desktop application, and I want to log into Maniac Corp. I'm going to use Azure to authenticate myself. So Azure is going to then ask me, hey, is this the user? Just another window. I'm authenticating myself through Azure AD, and perfect. Now I got access to it, but I'm not authorized. I've been authenticated through Azure, through AD. I have a log, but I'm not really authorized to do anything in any specific projects itself. So when we go back to ServiceNow and approve this request, so when we approve this request, so once again, we're here, approve, reject. I'm going to approve this request. Then a rhythm flow gets created, a change task gets initiated, and the process gets started. So when I dive back into Boundary, and I refresh this page, now I have access to my targets. And then this allows me to connect to my Linux instance. So I can click on connect. And now I've established a session. I can click on the shell, and it actually automatically SSHs me right into that EC2 instance for me to be able to do any of my commands, anything I want on the device updated for that limited time. And after that time expires, my access then will be deleted. So for example, in this demo, in the flow, we set a 30-second time limit. So then at 30 seconds, my targets would disappear, my session will be deleted, and everything I've done was recorded, sent to S3 bucket or locally to my worker for any auditing purposes I need. And we have a full trail from a ticketing and change management perspective inside of ServiceNow for us to be able to audit it. So I clicked on targets, refresh the page, click on sessions. Now I've lost access because that workflow itself was deleted. So really this gave me this break glass or emergency enhanced, so let's say security access to a device where I've used Vault and Boundary to kind of provide that just-in-time credentials and give me access to that device itself. So let's take a look at that workflow inside ServiceNow and show you how that looks like. So if we jump back into ServiceNow, we have our ticket here, and I could literally click on this rhythm. I can paste it inside of my tab. So we could search it, and we see the entire flow and the process of this request that was initiated. We see who approved it. It was approved. And we can take a look at the flow context of this, which then opens up Flow Designer. So let me just go to open the context. And we'll just click on here. And we'll go to our flow, which is Boundary Flow. So this is a simple way for us to build flows in ServiceNow. The first thing is we have that service catalog, which was really that enhanced screen that you saw when I requested something. So that's this is that service catalog that we built. Then inside of that service catalog or inside of this flow, we have specific actions. We get all the variables from that form. We ask for approval. Pretty straightforward, ask for approval. If approved, then ServiceNow is going to authenticate the boundary, so HCP boundary. And if we open this up, literally all we're doing in here is REST calls. We can actually integrate ServiceNow with Vault to grab these credentials too. But really, all I'm doing is I'm making a REST API call towards my specific method, and I want to authenticate. Then once I grab this authentication token, I parse the JSON, where I'm going to be able to parse this token and extract it into a variable. So then when I go to my Flow Designer page, I will have a variable in here that's just called tokens. And then I can drag and drop this token variable into the next flow, which the next flow is what we're doing in HCP Boundary is updating the roles. So if we open up this action, we have a REST API call that grabs the roles, authenticates it using that token that we literally just drag and drop. And if I X this out, I can literally drag and drop tokens. We parse that data through the JSON parser that it has. And then we give access or grant access to that device or that user that access. After a certain seconds, so for this demo, 30 seconds, then we remove access from that user and remove the role. And if we kind of jump into this to show this, it's the same concept. We're getting the latest version from HCP Boundary. We're parsing that data. And then we remove that grant. So we remove that access itself. So then that user does not have any, or that group itself does really not have any access to the device. So when we jump into our HCP Boundary environment in here, so right under projects, we have the AWS projects that has those two targets. We have our Linux target that's using that injected application credentials where we're injecting that SSH key from my Vault path. Here's where we have our roles. So we have specific roles for the platform team in here. And by default, the principals are an Azure group that my user is part of. So I can authenticate through Azure, do MFA, two-factor. But where I define the permissions is inside these grants. And this is where we allow specific actions or access to resources. And we can define those inside of ServiceNow or inside of Flow Manager, either using the REST kind of method that I've deployed, or you can actually tie this into Terraform Cloud, where then Terraform Cloud can actually make changes to HCP Boundary environment itself. So let's really take this and take a look at it from a quick example again. I'm going to go in here and request access to the platform team project demo. Let's just call this demo 1, 2, 3. I click on the submit. A request gets sent for an approval, which is all logged, monitored. The team now, VP manager now, or some team, security team has to, approve this request. We approve this request itself. And at this time, that flow gets kicked off. And then if we refresh the page, we'll see that a new grant has been created. So for this demo, just to give me wildcard everything access. So now when I log into Boundary, I now can see those targets itself. Log back into Boundary and refresh the page. We can then see access into our targets where we can click on the connect button, grab the secret, establish a session right through the shell that's provided us in here, and be able to do any types of commands and authorization itself. And again, after those 30 seconds expires or the specific time frame expires, then our session is dropped, killed, and we have a full recording of everything that was taking place for that user itself. So now we have no access, no session. Everything was dropped itself. And that was my demo of deploying this break glass or enhanced security solution that incorporates HashiCorp Vault and to kind of manage our secrets, Boundary to give us access into private infrastructure that has no inbound access to, and then using ServiceNow as our self-service catalog portal that is going to help us with that auditing and governance trail and that change management processes that we have in our existing environments itself. So just want to say thank you. And once again, I'm Sebastian Maniak. If you want to connect with me, just scan that barcode or hit me up on LinkedIn or my YouTube channel. Thank you very much.
Chris said it almost 30 minutes ago, but it is very true. Thank you, Sebastian. Super insightful. And I think my personal favorite, making something that is very complex to set up and has lots of sharp edges work nicely in a clean flow is just amazing. Yeah, well done. So if you've been following along for the past 2-ish hours, you'll know that we have a theme going on. You know, we're working our way through all the rough edges of deploying. We're figuring out how to deal with incidents, how to deal with database migrations. And of course, you know, 2023, the year of security, where we actually start taking security much more seriously, we can't leave out a talk on figuring out how do we actually detect when somebody is using our credentials. What patterns should we follow? What technology should we use? And I'm very excited to have my buddy Dwayne, who actually submitted this talk, to talk exactly about this. So with that, I'm not going to steal more of Dwayne's time. Dwayne, over to you.
Hey everybody, and welcome to my talk, Who Goes There? Actively Detecting Intruders with Cyber Deception Tools, here at HashiTalks Deploy 2023. Very happy to be here with you. So I'm Dwayne, I live in Chicago, I've been a developer advocate since 2016, and I'm also the co-host of the Security Repo podcast. Free podcast out there to talk about all sorts of awesome security topics. Hit me up on the internet at MC Dwayne, most places, or LinkedIn at Dwayne McDaniel. Uh, Feel free to email me as well, dwayne.mcdaniel@getguardian.com. GetGuardian's where I work. We'll come up with a couple points in today's talk, but that's not the main focus. We're here to help enterprises with their code security issues, primarily around hard-coded credentials and if they've leaked or have been breached. I'm happy to talk to you about that in depth. Feel free to email me about that or hit me up online. But that's not why we're here. We're here today to talk about cyber deception. But before we go any further, let me deploy something real quick. So I have this set of AWS keys and secrets. I'm going to go over here and make it look like I have made those a comment, and I'm going to go ahead and save those directly. And I've deployed that now. This is out live on the internet. We'll come back to that later. Just put a bookmark in that. That's kind of a dumb thing to do, though, because, well, we know attackers want your credentials. I'm going to tell a couple very quick horror stories of what could go wrong if someone gets your credentials or if credentials get leaked. And they're going to be scary. So I don't mean to terrify anybody. If you do feel, hey, I feel a panic attack coming on from these horror stories, just go ahead and recite the Bene Gesserit Litany Against Fear, and you will be fine. You will live through it. Only you will remain. The fear will be gone. I promise. Uber, we probably all remember this story from last year where a single attacker goes and phishes a super admin for their credentials. And yes, they have multi-factor authentication on before you think, well, MFA would have solved it. They had MFA on. The attacker flooded the requests for MFA, and eventually a thumb slipped or they got tired. We don't know the full story. Anyway, attacker gets in, finds a bunch of PowerShell scripts chock full of hard-coded credentials, ends up pwning everything, including their PAM. So they got into HackerOne and told them, hey, I'm hacking this, and they didn't believe them, flooded their Slack. Again, the company's like, this has got to be a joke. Next person you talk to is the New York Times, and that's why we know this story. Maybe this affected you back in January 2023. An attacker got in through a remote developer's environment and was able to steal a bunch of credentials from inside of Circle CI's infrastructure. They used those credentials to get into the customer accounts and started stealing customer credentials. Circle CI acted very quickly here and responsibly, and the best course of action they had was to rotate everyone's credentials, and that broke thousands of pipelines. Interesting note on this one: when this happened, a independent security researcher on the internet said, "Hey, all of my honey tokens went off. Something's gone wrong inside of Circle CI." So it says some advanced warning. So that's a little foreshadowing what we'll talk about in a second. And here's another story that really bothers me personally for a number of reasons, but it's kind of that perfect storm where a developer pushes and test environment credentials out to public GitHub, and no big deal, right? They shared a test environment credential. What could go wrong? Maybe somebody spin up some crypto mining or something. No, what actually happened was a second developer pushed real patient data into that test environment, and it took them about a year to figure that out. We don't know how many patients were affected. We really don't know the full scope of this. All we got was an apology from AstraZeneca. That's some of the ways that this can go wrong. But it all points back to the fact that attackers are going to exploit any chance they have to, or exploit any credentials they can find to get further into a system. We know how they behave. We've seen it time and time again. This is the MITRE attack framework. You land, you map the land, you laterally expand, you escalate privilege, you exfiltrate, you get out. Leaving out a few steps there, but that's the thing. Point is, we know how they behave. And if we're over there on the right, defending our stuff, if we're just putting all of our effort in defending, like making sure they don't get in, what do we do when they do get in? Well, what we need to do is react so fast to put them on their heels, and they don't know what to do next. And that's really the theme of the rest of this talk. We do know how they behave. Again, they can follow that attack framework, and we know what they're after. We know they're after data for reasons that start with an R and end with an ansomware. And they were for machine resources because they can spin up crypto mining, they can sell those machine resources on the dark web. There's a lot of things they can do with it. And basically anything that leads them back to one or two on this list. We know how they behave. We also know that there's this problem of leaked credentials, those hard-coded credentials out there in the world. That last year we found over 10 million hard-coded credentials just hanging out on GitHub Public. You can go read the full report over on State of Secret Sprawl report from GitGuardian to get all the details of what we discovered out there on public GitHub. But this is just a tip of the iceberg situation. There's so many other systems out there where we weren't looking. Places like Replit or just S3 buckets where people have thrown code. But we know this trend continues to get worse, not better, that people keep sharing credentials and hard coding them, making that lateral expansion so much easier. But since we know they always laterally expand and we know that this is a problem and they know it's a problem, we can use it against them. And that's the whole rest of this talk. We've been doing this throughout history. We're really good at this. We've been doing this for thousands of years, in fact. This might be arguably not part of cyber defense, but it's still an important part of cyber security today. Trojan viruses are still a thing. It looks like something, but something else inside. Looking strong where you're weak and weak where you're strong. Sun Tzu, gets credit with that for writing The Art of War. But we've seen this trope in a lot of places, and it's a pretty good tactic. Leave your opponent over here when we're really that's what we want them to do because that's where we're strongest. And we saw a good example of that more in the modern world back in World War II. This is a story, if you're not familiar with it, there's a great documentary called The Ghost Army. You can go view out there on the internet. Um, Basically, we didn't have enough tanks and planes and guns and everything to go hold Northern Africa in the early days of U.S. involvement in World War II. So we went to Hollywood and said, hey, what can we do? They built us these inflatable tanks and planes. And we were able to stage those very quickly and quietly and then distract the Axis powers to say, go look over here. Meanwhile, we snuck all the real tanks and planes and guns over and from another direction. And well, that's how we won World War II. Again, you can go find out much more about that. But again, let's make them think we're doing this when really we're doing that. Get to the modern era, where the term honeypot comes from. And Cliff Stoll over here, he wrote this great book called The Cuckoo's Egg that documents this entire story in awesome detail. But they also made a really fun to watch Nova documentary about this in 1990 called The KGB, The Computer and Me. Highly recommend watching this after Hashi Talks are done in your own free time. But basically, he was working at the Lawrence Berkeley National Laboratory, discovered that someone was getting in and stealing computer time. And not just with them, he started tracing it back and realizing, hey, this person went through all these other non-secured, non-classified servers that are owned by the government, owned by the military. Something's going on. So, in order to track this person back to where they were originating the call, and they went through a lot of hops, uh, his girlfriend suggested they add a lot of fake information, movie scripts, conspiracy theories, anything they can get their hands on. Let's add all of this to the server. 1985 download speeds are really slow. So, after a long time of trying to pull all this down, they finally were able to trace back and find this particular hacker. uh, won't spoil the ending for you, but it's a really, really interesting story. I highly recommend you check out. But this idea of honeypot was born from that. That's a sticky thing that it's going to take them a while to deal with and gives us an alert to know exactly what we're dealing with. This idea gets translated by Fred Cohen into the Deception Toolkit. Basically, if a system's not in use for a legitimate thing, that should tell us that anyone touching it is using it for an illegitimate reason. I'm oversimplifying it, but it's more of a set of protocol and set of um, standards than it is like actual technology implementation. But I highly recommend you go read it and dig into it for yourself. But it gave us what we think of today as the modern honeypot because it led directly to this a few years later. Alfred Uger said, hey, this is a real problem. We need to address attackers getting into your system now. I love this quote from him. Hackers aren't kids on a digital joyride to clear their motives financial gain. The term hacking comes from MIT, and it was engineering students playing pranks. That's what a hack was. Let's build a car on top of the dome. Let's attach a fire hydrant to a drinking fountain. Those were hacks. And about this time, around the turn of the millennia, uh, Alfred's like, no, these are gangs out to steal your stuff, to steal your resources, to do harm. Hey, here's a product ready to go. You don't have to go invent this. This is CyberCop Sting. Just deploy it, and you are ready to catch those perpetrators. Fast forward in time a little bit, and there's a conversation. There's a lot of conversations around honeypots, CyberCop Sting, and other systems like that out in the world. And Augusto says an interesting thing here in a very short message. Uh, he's been playing around with this idea of instead of honeypots or hosts or nets, uh, deploying something called a honey token. It's just a piece of information that shouldn't flow over the network. And if it does, something's wrong. Thanks very much, Augusto, because this launches a whole new realm of cyber defense, cyber deception, and cyber security. Uh, honey tokens, or I'm sorry, canary tokens are born a few years later. I'm leaving out a few things from the history here. These are the major high points, in my opinion. But a company out of South Africa called Thinkst, they're still around. We'll talk about them later a little bit. They build this thing called canary tokens, and you can go download the code for yourself. And in 2016, they introduced a fake AWS token into it. This is where I think we really reached the modern era of a honey token. It's not just this ethereal idea of information or a bit of data that shouldn't flow. It is token in the modern sense of I'm trying to do a thing. Here's the token to let me do it. Fast forward a little bit more and we get to this year. And I was very fortunate enough to be at RSA in 2023 and see this talk by Kevin Mandia. And he says basically the talk is we can defend with hardening our walls and our defenses all we want. We're still probably going to get breached at some level at some point. There are apex attackers out there. You can go watch this talk yourself. It's on YouTube. But basically, toward the end, he starts saying things like, we just need to make sure we're aware when they get in. We need early warning signs. And there at the bottom of the screen, you see honey tokens, account bait, as he calls it, are those early warning signs. I was very fortunate again to be able to take this picture back at RSA. But that gets us to the modern era. And that's what we're going to talk about the rest of this is like, what is a modern honey token? How do you build one? And what are the best practices around it? In about the next 15 minutes we got left. So just to level set, because I did throw out a couple different variations of the term honey token, including the Gusto's original exact words. In the modern world in 2023 and moving forward, honey token really is a decoy credential. That's how kind of the whole industry looks at this problem set. It looks like a real credential, it looks like a real thing, but when you go to use it, it doesn't work. It doesn't go to anything. Instead, it triggers an alert on your side of the world to let you know that someone's tried to use it. Very importantly, they look identical to real credentials because they are real credentials. This is one way to build a honey token. Let's dive straight into the architecture. I love architecture diagrams. This comes from GG Canary, which is our open source honey token building uh, code. You can go download it yourself. This particular diagram isn't in that repo. It's in a blog post you can find by looking on our blog, GG Canary, here at Git Guardian. But basically, it's two Terraform scripts. The first Terraform script says, build me a bunch of users. They don't give them any access, any privilege whatsoever. These are zero access privileged users. And let's store those users in a list. Now let's set up a Lambda function with another Terraform script. That Terraform script is going to take that list that we made, store it in an S3 bucket, and then watch for people trying to use anything with related to our account, which we can easily do with CloudTrails. If the Lambda function matches something on the list with something in the bucket, go ahead and send an alert out over Slack or SES or SendGrid to let us know that something has happened out in the world. This is one way to build them. This is one way to think about them. But basically, we have real credentials that don't go to anything, a way to check and see if they're being used, and an alert system. That's basically the fundamental pieces you need. Like anything else in technology, there's a good argument for building it yourself because you can understand it. There's no black box element versus buying off the shelf, which brings scale and automation with it. And I'm going to talk about both, but I would encourage you to go the DIY route if you are a technology person who wants to understand how the sausage gets made. You can tinker around with this. There's a lot of ways to experiment. Just go back to Augusto's original message in that thread, a piece of information that shouldn't move. So if you're working in a Windows system, I think there's a tool out there to watch. I think it's called File Watcher or something like that, where you can watch and see if a file moves around. So you can play around with this idea all day. But when you start getting serious about it at scale, especially around code security, that's where I would say go look at the examples from open source. GG Canary is a great one, and I already talked about how that works. Space Siren, special shout out to them. Space Siren is a project that picked up the work of Space Crab, which was an earlier implementation of a honey token. Um, it does require some AWS knowledge, but it's pretty straightforward on how to build these things and how they work. Not that much different than what we did with GG Canary. And then if you want to see how Canary tokens are built by Thinkst, they open source their tooling. So if you're building this, remember that it's going to be up to you to maintain and deal with all of the ramifications of these things. So if you need an enterprise solution, congratulations, they exist. You don't have to go build this yourself. I would start with that one on the top if you're just experimenting and you've never heard of a honey token before. Canarytokens.org. They're free one-off honey tokens. I'm not going to go to the site for right now for sake of time, but you can go set up fake email accounts, fake SQL files, fake Excel spreadsheets, most importantly, fake tokens, even fake credit cards these days. But for one-offs, set them, forget them. It's not a bad system, but again, it's scale-wise, it's very limited. They do sell that at scale, that same tool. It's called Canary.tools. Not going to get into the commercials of that. Let you explore that again for sake of time. Here at GitGuardian, we make one. It's in addition to our platform, so it's not a standalone product. Since we're looking out for hard-coded credentials, we think it makes sense to know when they got leaked or when you've been breached, and to know what else is in that account. So we cross-reference all that data for you. If you're a customer, definitely talk to us about that. And if you're looking into GitGuardian, well, that's another reason to look into us. Microsoft Sentinel has this built in. It's Azure specific, and I do not understand the inner workings of it because I just haven't spent the cycles to look. But if you're using this in production, let me know. I would love to have that conversation with you on how your mileage is gone. I know CrowdStrike sells this as well as part of their offering. I'm not a CrowdStrike customer, so I can't tell you exactly the ins and outs of it. But I have had a conversation with the Proofpoint team that builds Identity Threat Defense Shadow, which is what they call theirs. It's a really interesting honey pot solution that has a honey token element to it. I'm not going to say more than that because I would do it a disservice, but these are just some of the options out there. My point is, if you want to do honey tokens at scale, there are a lot of ways to do it that you don't need to build yourself. No matter how you arrive at the actual honey token in hand that you deploy, there's some best practice for you. So first, put them in private environments. Anywhere where someone has to log in, if it's behind a thing, behind some kind of authorization, that's a probably good place for it. Not just your code, not your private code bases. That's a great place for them, but also in your CI environments. Anywhere that's got a text field that I would need to be logged in to be able to see this. Since there's no legitimate use for them, there's not a real danger of a developer just picking them up and saying, I wonder what this goes to. Let me see if it's valid. I highly doubt that's going to happen. Same thing with Jira or Slack. We highly recommend putting them in vaults as well, your vault systems, because if someone's breached that, well, they have your keys to pretty much everything, and you want to know immediately that something has gone wrong. Do use a 1-to-1 ratio. Put one honey token in one place and then make a new honey token to go into the next place. You don't want to have the scenario where you've deployed the same honey token to 100 things, because the honey token goes off, gives you an alert that someone has tried to use that honey token, and now you have to do some investigation work, put on your Sherlock Holmes hat and figure out which of these repos or which of these environments was in fact exposed. You want to know immediately, this honey token went off, that goes to this base only. No other honey tokens went off, great. Now I know that I've got to deal with this one repo or this one environment. Do think in terms of automation. Yeah, you can do these onesie twosies one off by hand, but once you start thinking in terms of all of your repos and all of your developers and all your lines of code, then it's pretty obvious to think, well, I need an API I can hit and just deploy these. Some commercial systems offer one, some don't. Your mileage may vary on this. GitGuardian built one. I built a sample automation script. Won't make a lot of sense because I didn't write a lot of documentation for it, but just gets the idea of check and see if there's a honey token. If there's not, build one and let's go deploy it. And unless you specifically are a law enforcement agent, think about this in terms of blue team. You're using this as a defensive tool to cut dwell times. Like, I don't recognize this IP address. This IP address should definitely not be touching our code. Let's deal with that situation. Let's defend. That's disallow list. That's whatever we need to do. Adjust WAF rules, however you do it. But just think in terms of what else has been exposed and how am I defending what I own. You can easily fall down this slippery slope of going after someone and crossing some international lines without meaning to. So think in terms of defense, not offense with this. And like everything else in tech, this is going to be a journey. It's not a one-off exercise. Start with one repo, start with one place like Jira, and move out from there. Once you understand you're really comfortable with it, that's when automation is going to kick in for you. And you're going to see, obviously, we should be doing this every time. And once you start thinking that, well, that's where automation comes from. And let's go check on that honey token I pushed out in public earlier. So again, I'm using the Git Guardian dashboard for this. And I see that that's what I deployed. 21 minutes ago was how long I deployed it. Or actually, that's when the first alert came in. So wow, yeah. It's been 11 times it's been hit out in public. I see the first one was from AWS. That makes perfect sense. I'll get to why in a minute. And then I see, hey, there's some people I don't recognize from India, and I don't know this. Don't know what that address is. I know what these are. I think there's Git Guardian specifically scanning it because honey tokens aren't meant to be deployed publicly. What I did basically is something you probably shouldn't do. If you put a honey token in a public place, a scanner is going to hit it. There are all sorts of scanners out there. As showed, AWS hit it first. They're very serious about scanning for their own tokens on the internet. A lot of systems have them. Git Guardian, of course, we build one that's constantly scanning GitHub public, and that's where I deployed that one. But they're going to get triggered. In fact, the same thing that triggers those public scans isn't they just reading it. Someone just reading it isn't going to do anything. It's then they tried to use it. And not that they maliciously tried to go do something bad with it, they just tried to validate that it in fact exists and that it goes to something. There's a lot of validation step built into a number of tools, including Git Guardian, including Shufflehog, which you saw over there, that just quickly check to see, hey, does this work? Especially with main systems like big systems like AWS. So those automatically trigger it and say, yes, in fact, this doesn't work, but the act of trying is what actually sets it off. So in conclusion, if we just play defense, it's really hard to win this game of security. Keeping them out should be our goal, but also kicking them out once they get in should also be part of that goal. They're going to get in, we just have to live with that reality. Every second you can push them back on their heels and make them think, the attacker think, I don't know what to do next. This isn't in the playbook. I got bounced from the server after being in there for 3 minutes. I don't know what to do about this. Oh, and by the way, I did not show this. I probably should have. I have an alert here on my phone from 20 some minutes ago. My honey token was triggered. So I got this alert on my phone pretty much right after I started talking, right after I deployed that honey token. That showed me immediately, I got an alert. I just didn't show it on screen because, well, I didn't. Maybe I should have. But we need to push them on their heels as fast as possible. Honey tokens are a very clean way to do that. They're a very efficient way to get that alert quickly so you can act on it immediately and cut those dwell times down to minutes and not hours or days. You're not on your own. You can go build these yourself, but there's a lot of commercial options, like I already showed. And again, you're on defense probably if you're watching this. So make sure that you're aware that someone's in there poking around or that your code got leaked. If a public scanner hits it, that means it got leaked. If it not public scanner hits it, then it's probably an individual trying to breach you or they've already breached you. So think in terms of how do you defend in those situations. But I'm out of time. I'm Dwayne. I live in Chicago. Hit me up on the internet to talk about this or pretty much anything else. I'm also the host of the Security Repo podcast. Definitely go check that out. And again, thanks for being on my talk here at HashiTalks Deploy. If you have any questions at all, hit me up on the internet at dwayne.mcdaniel@gitguardian.com. Thank you very much.
Beautiful. Listening to Dwayne is always a pleasure because he makes hard things easily understood. And I think there's just so many great concepts to pull from in this talk. Bring the right mindset when you're defending your infrastructure, no matter if you're trying to play red team, no matter if you're trying to play blue team or anything else. And, let's go with that. So a couple hours ago, 2 hours ago, we had one of our viewers ask, should I be watching HashiTalks? Should I be playing with a Nomad 1.7 GA? And this is an existential question. I understand this problem. I too was conflicted. So we solved this. We solved this in the only way that we could solve this, which is we brought somebody from the Nomad team here, because when you have a good thing and you add a second good thing, great things happen. So it is my pleasure to introduce Phil to all of you, who we're going to magically make appear on screen, hopefully. There we go. Hey, Phil.
Hey, how's it going?
Pretty good. Now even better, because I know you've got some amazing stuff for us. So for the folks that have never met you on one of our office hours, what do you do for Nomad?
I'm on the Nomad engineering team, and mostly I work on the UI, although some of the stuff we're going to talk about today is where I dip into the command line and a few other fun places.
Love it. So 1.7, obviously, big release. Many big releases this year, which is great. I mean, there is so much good stuff coming out. What's your personal favorite? What are you most excited about?
There's a lot of stuff. I'm really excited about NUMA-aware scheduling. It's something I want to play around with. But the thing that I am very biased towards but want to talk about today is Nomad Actions. This is something that we've been thinking about for a long time. Got a community issue for it about a year ago, and support for it built internally. And I'm pretty excited just to kind of go over it with everybody today.
Well, I think why don't we switch on your screen share, and let's see what we can see here. So release notes are available for the beta on the blog. I know we have other material coming out.
Yeah, if you haven't had the chance to take a look at it, feel free to read through the blog post. There really is a lot of stuff. This is the section that I'll be talking about today: Nomad Actions, or you might call them Nomad Task Actions or Job Actions. But basically, the expectation here is that we know a lot of people use things like alloc exec inside of Nomad. Maybe they hit the endpoint, maybe they use a command line interface, maybe they use the UI for it. But no matter how they do it, we find that people end up using this kind of like a break glass in case of something happening situation, right? It's a bit of a foot gun for people. So they have to use alloc exec to do something like clear their cache, or use alloc exec to do something like roll back a database migration. But every time they do this, they have to kind of remember exactly what to do once they're in there. They need to remember to pass in the correct credentials. They need to remember what their identity looks like, things like that. What we want to talk about today are Nomad Actions. These are reproducible ways that Nomad job authors can define actions to be done by other operators and give out access to these actions to those operators, which means that if you want to do something like have availability for a database rollback or database migration to take place, you don't have to give somebody full like SSH access into your box. You can just say, make sure you have access to this Nomad job, and you can run an action against the allocations of it. I know that was a mouthful, so I'm going to start to go through it. Hopefully now is okay to do that. All right, so you should see my my Nomad screen right now. What I'm going to show you is this existing system job. If you haven't taken a look at the Nomad UI in a little while, this is what it looks like. And I have one allocation running. It's in a group called group and a task called task. So I'm not too original here. I'm going to click on
quick
exec.
question from the audience. Could we zoom in just a little bit so we can
Yeah,
see all the visual goodness? Thank you.
Sounds good. All right, so I got a group called group, task called task, and I'm going to exec on this allocation. So I'll click the exec button, and it launches an exec window. If you haven't seen this before, that's what we're playing around with. It gives you a live session on the box that this is running on. So I'm just going to enter into my shell, and I can type something here that I want to, like curl weather. Get a nice display out from here. I can do what I want to, right? I can echo hi. I can say hi to the deploy talks, whatever I want to from here. But I have to remember not to, fat finger my command. I need to remember exactly what to do. If I, for example, try to curl my weather, but I don't specify Toronto, it thinks I'm in the wrong place. It thinks I'm in Thornhill, which is about 30 minutes away. The point is, it's really easy to, when you're doing these things ad hoc, forget about exactly what you wanted to do when you started running the exec session in the first place. So take a look at what we can do as of Nomad 1.7 launched today, by the way. You can go and edit your job template with a format that looks an awful lot like what task configs look like themselves. And these new items are called actions. So we're going to write a new action. We'll call it weather. And we'll define it more or less in the same way that we define any other task config. We're going to give it a command. And that command is going to be curl. Also give it some args. And we're going to make those args in the same format that you do anything else in Nomad tasks. It's reproducible weather action. Plan it, make sure it looks good. We're adding a new action. And run it. This allocation will update. It happened so fast you didn't even see it. And in addition to the exec button that you see up here, we also see an additional button that says actions. We have one, it's called weather. If we click it, you can get this nice little window that tells us everything we want to see. But that's just the UI, and it's kind of neat. There's no way to fat finger make a mistake on this, right? It's built into the job spec. And I'm not the only person that gets access to this. If I have other access credentials, other operators that have access to this job, they can also run these actions. I can also run it from my terminal. So if I want to, I can say Nomad action. Let's go to that one. Run weather. All right, here's what the fingerprint of this looks like over my right side window. I'm calling Nomad action or Nomad job action. I pass in a group, I pass in a task, and I pass in the job. And then whatever the name of the action is what it'll run. Forgive my terminal being very zoomed in right now. But this is pretty advanced. For example, you can add some more complex jobs to this if you're so inclined. I'll add in a action. How does my work? Party action. I do that same thing, but call party. Should see everybody's favorite animated party parrot. Okay, these are kind of trite examples, but I hope that they illustrate sort of what actions are about. You define what the golden workflow of doing something is, and you let operators run against it as many times as they want to. Like exec, it lives kind of in an ephemeral state. So what takes place there, you would have to log out on your own. Otherwise, it's just like operating on a machine. But there are plenty of ways to make that output affect something else. I'm going to give you an example of this. I have this actions-laden job called Redis actions. As you might expect, it is an instance of Redis key value store. If I can pop into one of the tasks for this, the Redis task, you can see that my logs are just outputting how many entries are currently in my database. But I can also do some things here. In addition to on the job level, I also at task level have the ability to do certain things. So I'll add a random key. I'll add some random temp keys, which have temp prefixes on them. Clear these out. Let's list what keys I have right now. So there's a couple of normal looking ones and 2 temp ones in here to give me a total of 8 keys. And if I check my logs again, I can actually see that some things are taking place. These actions that I'm running are modifying the behavior of the allocation that's currently in flight. That's, again, kind of a trite example. You might want to do something like clear your cache, which if I hit flush temp keys, that kind of emulates that. It's removed 2 of the keys. My 8 has gone down to a 6 in my logs. I can toggle save to disk to off so that any further changes won't persist from Redis. I can do all sorts of things that have real world use cases. But that's not the only thing. We can also do things that are long-lived. These are all kind of one-off actions. But what if you want to do something like stream information? Well, that's available to us here too. So let's go ahead and take a look at health check. This is going to run every bit that it can, and this is going to give us a Redis latency check. It's a pretty long window, and it's going to continuously run until I tell it to explicitly stop. But it tells us what our average min and max latencies are to hit this instance from where we're running it. This looks even nicer inside of actual terminals with all their goodness to be able to handle escape characters and things. In the browser, it's still a pretty naive implementation. But it should hopefully show you exactly how you might be able to go in and do some repeated jobs, whether they're monitoring a situation, whether they're porting logs out to some other service in a non-ad hoc way, whether you're cleaning up your cache or migrating your database or rolling back your database. We want to give Nomad job authors the ability to run these things and let others run those things so that they don't need to page them in the middle of the night saying, hey, can I get SSH access to this machine? Well, in fact, just try and run the Nomad job action. The footprint for it here looks a little bit big, but I also want to encourage people to know that you don't need to pass in group and task if you know an allocation ID. So you might run into situations where you have multiple different allocations all running the same task. For example, here I have two groups. Group 1 has 1 alloc on it, and Group 2 has 5. If I go into my actions for this particular job, I can see some of my basic actions will run on the allocation in the only allocation that exists in the group I'm running it. But I also have a group of 3 different allocs in it. For those situations, we give the user the option to run on a random allocation. This is the default when running a command line action for a multiple allocation group. Or I can run on many all at once. And the UI is smart enough to group these things. We'll give you these different allocations. You can kind of click between them and see what's going on, noticing that the allocation ID is changing between them. In the UI, we know that these actions aren't terminated immediately all the time. So once you've run some actions, we give you a new persistent global button, and you can go off and do other things inside the UI, like check out your evals or take a look at your topology, do whatever you want to do here. And there's a quick and easy way to get back into these. You can click on the buttons, or if you're a keyboard aficionado, you can just type in AC and they pop right back open. And this gives you the ability to stop one allocation's task action, stop all the task actions within an allocation, or stop all actions for all allocations in all jobs. So a pretty high degree of control for these, what we want to call golden workflows or actions. Okay, that's the high-level overview. I hope this makes sense to users. I'm showing off the UI a little bit because I think that the implementation here is pretty clean. I expect most of the time people are going to use this is going to be through the command line. But I do want to also encourage people to think about the API endpoints for these as well. These are built to be pretty extensible. The actions I'm showing are not too difficult. But you could write an action with as much complexity as any Nomad job specs task, and it operates more or less the same way. Just think about if you would exec it historically, now you can start making it into an action. Thanks.
If you would exec it, now it can be an action. This is the perfect takeaway from this. I love it. I think Shantanu has a good call out here. Make it easier for people to onboard to a system and they will appreciate it more. I think that's definitely the case. Beautiful demo. Also very last minute, I appreciate that. We weren't sure we were gonna have this in there, so I'm super excited that we actually got to have it in there. Thank you for playing along. And so before we switch to our next speaker, I'm curious, why Numa? What do you think? What are you excited about it? The other big 1.7 feature.
There's a few in there that I think are really cool. Numa kind of gives me the ability to think about Nomad in a way that I hadn't previously thought about it, right? When I think about how I set up my allocations, I have like a very front-end developer working in the back-end world way of thinking about how these things get placed. But Numa means that I can think about more advanced ways of placing jobs. So I'm excited for that. I don't want to have to think about how to be as efficient on the hardware that I have as I can be. I just want my job runner and orchestrator to handle that for me. There's enough things to worry about.
I like this answer. Very helpful. Shantanu, great question. Definitely something we will be talking about, but it's going to be an office hours and not at deploy because we have other amazing content that we want to talk about. Maybe we'll even bring back Phil because I know we have more questions for you and more beautiful demos that we could possibly have. With that, thank you, Phil. Please enjoy the green room. All beverages are free for you, and we'll bring in our next speaker.
Well, hi. I'm back. Oh, no, wait. Are you on mute again, or is my
No,
audio
I'm just mouthing.
you're mouthing. Okay.
Yeah, on purpose. No, we missed you, and that's why we brought you back. So this is exciting. Also, Chris challenged me if I could be on mute twice today. So Chris, here you go. We reach for the stars, and we made it.
It breaks up the monotony. There you go.
It breaks up everything. You know, like if everyone cracks up, that's all we need. With that, I'm curious if we can talk maybe about redefining words and figuring out new ways to define that which we think we know and understand.
Yeah. I know. That's a good segue. I'll try to make this fast so that we have our next speaker queued up. But it occurred to me that we didn't actually define deploy that well. It's called HashiTalks deploy, and we never actually talked about deploy. So I do have a small diagram up. And I think it's been helpful to think about how we think about deploy and what the definition is, right? Because I'm pretty sure that it's changed a lot depending on what organization you're in, how you're approaching it. So let's talk about the new definition of deploy.
Awesome. Stage is all yours.
Thank you. All right. So hi, I'm Rosemary. I'm a developer advocate at HashiCorp. And well, I realized that we needed to talk about the definition of deploy. And the definition of deploy is probably better described by how do we deploy. It turns out we exist on this interesting spectrum of how we deploy, right? First, we can say we deploy things as code. This could be something like Terraform apply on your local machine. This could be something like, kubectl apply or Nomad. Anytime you schedule a Nomad job, anything that you do on your local machine, you've probably done as code. And then you've got these deploy bundles now. We've gotten to this point where more and more deployment requirements are being added to our applications and our infrastructure. So now we have bundles. These are things like modules or manifests. So anytime you have a Helm chart, anytime you have a Nomad pack, anytime you have Terraform modules, right? These are bundles that you eventually start deploying. And where other people may have developed them, other people have abstracted away all the complexity, and you now just deploy bundles somewhere. And then we talk about UI CLI. We have always deployed by UI CLI. I would say that's the first way that we've deployed in the past, where we've sort of SSH'd into a machine and then copied things over. Or if you've gone into a UI, you've clicked and you said here, I'm going to schedule my resource on here. But the spectrum actually is very, very, very large now. And the reason why is that we continue to have all of these different ways of deploying, right? When we talk about deploy, it means that the way we deploy changes. There are things that are lower level, which give you customization, and higher level, which give you standardization. And there's a nice benefit to having customization. If you're on the lower level, you're doing things as code, you have greater control of the way that you deploy. Even if you're doing pipeline as code to a certain degree, we can argue that's bundled, right? You're bundling your pipelines, but even individual pipelines and defining everything as code, you have a greater control of how you deploy. And it's something that you need for day two operations, right? This is sort of your foundational level. If you can do something as code, or you can deploy something as code, you have a lot of control over it, and it's required for day two, and anything that is beyond that. But then you also have more opinionated deploys that you get from like sort of UI CLI approaches, right? These are things that we're progressively wrapping around bundles. We're wrapping around things as code. And, there's a complexity to it, right? There's a complexity of someone maintaining that kind of standardization, but you get a more opinionated deploy. And that's why we considered it great for getting started. So if you're looking at this, right, now, deploy is complicated. It turns out we deploy in these different ways. We deploy with the pipeline escape hatches of as code and deploy bundles, but we also are heavily going back to a wrapped UI CLI around all of these pipelines and deployment workflows, partly because it's getting more and more complex. So of course, as things get more complex, we start to build it away. And so that's where you get, something like Waypoint templates. And I briefly show this because it's funny. I thought that, we were all in the place of saying like Terraform apply and using bundles and bundles of Terraform configuration. And now we've kind of gone back to looking at UIs or portals for someone to just kind of get started. So in the case of Waypoint, HTTP Waypoint, if you haven't checked it out, right, the idea is now you can provision a Terraform module and you configure some settings, you fill in some forms, and it generates a GitHub repository and everything else, and a Terraform run. And these are things that people don't necessarily need to know. They don't need to know Terraform directly. But if they need to make changes, they do need the escape hatch of Terraform to go back to. And the second part of deploy that I think we talk way too much about, but we don't think about now how it's changed, is how automated is it? And this, just very quickly, you'll hear a lot today about people, discussing DevSecOps or how we're deploying, right? And it ranges from continuous integration, continuous delivery, continuous deployment to now GitOps. The spectrum is interesting because you're still using continuous integration. You're still doing continuous delivery. If you're doing a Terraform apply, you're probably not going to do auto approve right off the bat. You're going to have a manual step of approval in the middle. And continuous deployment is now something we're being a little bit more, we are embracing a little bit more. I think that now that we're able to assess the risk of changes to our systems, whether it be application or infrastructure, and we're having a better automation and metrics around it, it's easier to do continuous deployment now than before. And then now we've kind of gone to GitOps, right? Where it's absorbed the idea of continuous deployment to a degree where we're just automatically reconciling any system changes as long as they're consistent with version control. And again, recognize that it's a spectrum, right? If you're on sort of the lower level end of the spectrum, it's a greater control of how you deploy. And then if you're looking at GitOps, it's a very opinionated way you deploy changes, right? GitOps is looking at version control changes and saying, okay, does this match to the actual state? And it's very opinionated. It's basically saying, my opinion is that version control is the source of truth. So I'm going to continuously deploy until I achieve the source of truth. And along the spectrum, we also have to acknowledge that deploy is manual. We're not fully automating it. As much as we try to automate as much of it as possible, we have more manual emergency changes that still require us to go into systems, do break glasses. That's what we were talking about with Nomad actions as well. There are times where you do have to do manual changes, or you do have to do a manual approach to integrating changes into your systems. And you do have to have a lot of control over how you deploy those changes versus more automated changes, which are more regular. So that's reconciling drift or common changes to systems. So overall, I'm not going to go too far down this rabbit hole further, but in summary, establish an escape hatch. As much as we enjoy automation and we like to highly automate all the things, including our deployment, you do need an escape hatch, whether that's in the form of someone committing to version control or even a break glass situation where someone has to have the ability to SSH or get into an instance, right? And use version control as a source of truth. We're moving toward that. So even if you're doing manual changes or you're on this continuous integration part of the spectrum, start with manual and eventually sets the foundation for you to get more automated. And when we talk about deploy, right, which is pushing to production, deploy automation heavily depends on context. I'm not saying that we should always automate all the things and deploy automatically all the time. But there are certain contexts where it makes a lot of sense and certain contexts where it doesn't. With that, thanks for having me. And I'm excited to hear the next speaker.
As one of the people in charge of selecting the program, I can say I'm excited about hearing all of our speakers. This is beautiful. Thank you for sharing these ideas. I love the idea of always building in an escape hatch. It is true, we strive for perfect automation, and I know, we'll talk about it at conferences, we'll talk about it as if we've achieved that, but we're always continuously building towards that. It's a journey. I think Dwayne said that really well, so thank you for the amazing talk, Rosemary. With that, we're going to be talking about creating ephemeral preview environments with console service mesh. Very excited about that one because that's going to help us figure out where we need to place our escape hatches. So with that, Amarnath, over to you.
Hi, everyone. Thank you so much for taking the time to attend this session. So I'm going to be talking about how you can speed up the microservice development workflows for your backend engineers by providing them with ephemeral preview environments. So my name is Amarnath. I work as a staff software engineer at a fintech company called Funding Societies. We are based in Singapore. So we provide digital financing and payment solutions to businesses in Southeast Asia. You can find us at fundingsocieties.com. So our journey with the console service mesh began in 2019 when we felt that we had outgrown the previous service networking solution that we were using. So we evaluated the service mesh software available out there and eventually picked Console Connect. By the end of 2020, we had moved about 40 microservices over to the mesh. Last year, we started running our sidecars independently from our service containers. Earlier, they were bundled together. Operationally, this was a big win because we could now upgrade our mesh infrastructure without affecting the product teams. So this year, we've been exploring how we can accommodate serverless artifacts like Lambda functions in our service mesh. We've also been trying to see if we can take some of the features available in the mesh to provide some developer productivity benefits to our engineers. And that is how we explored this path of seeing if we can use the mesh to provide our engineers with ephemeral preview environments, which is what I'm going to talk about in today's talk. So let's jump right into the problem. So most organizations have a staging environment. Some call it UAT, some call it pre-prod. Despite the name differences, they do have some common attributes. So the staging environment is typically shared. It's shared among developers, testers, even product folks. It is also isolated. It's a replica of production, but it runs in its own network. And some organizations access to the services and applications might also be restricted. You might probably need to be connected to a corporate VPN before you can access the applications on staging. So the data in this environment, as expected, is synthetic. However, the environment is treated as high fidelity, mainly because of its resemblance to the production setup. Since only one version of each microservice can run in this environment, deployments typically happen from the default branch of the service repository. Acceptance API tests also run against the staging environment. So the idea here is that we should be able to catch issues in the release candidate before and fix them on staging before they're promoted to production. So here you can see how typically code and schema changes get promoted from staging to production, and masked data samples get synced back from production to staging periodically. So the shared nature of the staging environment introduces some problems. So let's look at some of the developer pain points. So the first is the slow feedback loop. So developers will have to wait for their pull requests from their feature branches to be reviewed, approved, and merged before they can test their backend changes from front-end applications on staging. Also, as we saw, since the acceptance API tests run only against the staging environment, issues, if any, that were discovered will have to be fixed in a separate PR, and the developer will have to go through this workflow again. So to mitigate this, we provide escape hatches to developers to deploy right from their unmerged feature branches to the staging environment if they require to do so. However, even with this, since only one version of a service can run in this environment, manual coordination is needed among developers working on the same microservice to figure out in which order they need to deploy. So you can imagine an engineer going something like, hey, can I reserve this environment for a few hours so that I can deploy my version and then test it, and then I can hand it back to you. Now, this is not ideal because we typically don't want our engineers to step on each other's toes. Another issue is also that because we allow engineers to deploy from unmerged branches, a bad deploy can have a cascading effect on other services and affect the reliability of the environment as a whole. Now, this is a real problem because the environment has multiple users, and you really don't want to be affecting someone else's work inadvertently through a bad deploy. So the question really is, can we provide backend engineers with isolated environments where they can test or preview their changes before merging? So if we look at the solution landscape, it becomes pretty clear that this is largely a solved problem in the front-end space, both for web and mobile applications. But it still remains an open problem for microservices-based backend systems. So let's try to come up with a solution for it. So the first idea that comes to mind is, can we provide complete isolation? So this means spinning up like a full-blown environment with all the services and the resources needed for each pull request opened for any of the service repositories. Now, while this might work for small teams and small set of services, as the number of services increases and the team grows, this quickly becomes untenable, primarily because it can get prohibitively expensive to run full-blown environments, multiple full-blown environments for every pull request. The second also is the amount of time it takes to provision such environments, because beyond the time it takes to deploy, you also need to think about installing the database schema, seeding data, etc. And that quickly adds up. So what I'm leaning towards and what we'll be looking at in the rest of the talk is actually multi-tenancy. So the premise here is that the staging environment is already good enough and we want to reuse as much of it as possible. This includes the baseline services that are deployed there and all the other resources. We want to see if we can deploy ephemeral variants of our services that can run in the same environment along with the baseline versions. And finally, we want to see if we can isolate at a request level and figure out some sort of a smart routing way to ensure that the requests made are sent to the right versions of the services that we are interested in, right? So before we lay out the requirements a bit more clearly, let me introduce this reference system that we're going to be using for the rest of the talk. So imagine that this is the staging environment of a sliver of an e-commerce backend. So you see a few microservices here, and they're written in different programming languages, which is not very uncommon. Each of these services are also part of the service mesh. So you can see the Envoy sidecar proxy running alongside each of them. Each of them are also integrated with a tracing client to send spans for distributed tracing, which has become quite indispensable these days. So what you see at the top is the API gateway, which is your edge proxy, load balancer. So all requests from users, front-end applications are received at this proxy, and then it sends it upstream. So the checkout service is something like a backends for front-ends kind of service, and it has the payment and currency services as its upstreams. So the payment service is a direct dependency, while the currency service is one hop away. So the first requirement that we have is, can we capture user intent in a flexible way? So what I mean by user intent is basically the user specifying which versions of individual services they are interested in accessing, right? And sure, we can easily do this with HTTP request headers, and they compose really well also. So you can have multiple headers to specify the versions for each of the services that you might be interested in testing or previewing. So in this case, as you can see, we are using convention, X preview prefix. But after that, we have the name of the microservice and the version of it that we want to access. So I've represented the version here using the pull request number, but alternatively, you could also use something like the feature branch or the git commit hash, for instance. So the second requirement is, can we run multiple versions of our services, basically the ephemeral versions of our services in the same environment alongside the baseline. So what we want is, as you can see here, you have the baseline payment service version already running. Can we also run these two variants? And as you can make out from the service name, they are deployed from individual PRs. And similarly for the currency service, it has one variant running alongside it as well. Can we do something like this? The answer is yes. So in a cloud native setup, it should be pretty easy to use a container orchestration tool like Kubernetes, ECS, or Nomad to deploy multiple versions of your services. So the third requirement is, can you propagate user intent to all the services that are seen in the request path? So what this means is that we are able to receive the user intent as request headers at the API gateway, as we saw in our first requirement. But the question now is, can these headers be propagated automatically to all the other services that are seen in the request lifecycle? Now, the API gateway being a reverse proxy does this automatically, right? And the Envoy sidecar proxies, also being reverse proxies, do the same. However, the custom microservices like checkout, payment, and currency might not exhibit this behavior out of the box, right? So to fix this, we might probably need to make some code changes in each of these services to do what we desire, which is to read the request headers and then automatically inject them in all the downstream calls made as a part of that request lifecycle in that service. What makes this a bit challenging is because there are multiple programming languages at play here. So if you were to do this, we probably need to build libraries in each of these languages and then update our services to use them. The question is there a different way? Is there another way that we can think about this where we don't need to put in as much effort? The final requirement is the most important one, which is, sure, we have the user intent supplied as headers to the entry point. We have figured out some way to propagate them to all services. Now, how do we use them to route the request to the right versions of the services like we desire? So this is a bit tricky to achieve. And again, what we want to see is how can we do this in a way that can scale automatically with the system, right? So what we're going to do first is look at the tools that we already have at hand and see if we can find solutions with some of them. So the first is distributed tracing rails. As we discussed earlier, each of our services have a tracing library that we're using for distributed tracing. What this implicitly means is that the rails to propagate the tracing context already exists in our distributed system. So the only question that remains is, can we piggyback on that rails to propagate our ephemeral context also? Turns out we can. So the OpenTelemetry protocol has a feature called baggage, which allows you to attach custom attributes to the tracing context, which is then automatically propagated through the network. And this has built-in support for the HTTP carrier. So what this means is that if we follow a specific convention with respect to the way we name our HTTP headers, in this case we're using OT-baggage, then the tracing libraries will automatically ensure that these headers are propagated to each of the services in the request lifecycle. Now, this is pretty cool because we're able to take advantage of our investment in distributed tracing and then use it for solving a completely new use case. So in the console service mesh, you might already be aware that the console client and server agents together form the control plane of the mesh. So to me, what the control plane gives us, I feel, is that is centralized configuration with decentralized enforcement. So what this means is you can define configuration policies for your service centrally, and then which is evaluated by console, which then propagates the associated changes to the sidecar proxies of all the downstream services automatically where they are enforced. So console calls these policies configuration entries, and we're going to be taking advantage of two of them to solve some of the problems that we have. So the first is the service resolver configuration entry. What this lets us do is basically segregate the service instances that operate under the same name into different buckets based on some criteria. For example, here we're defining the service resolver for the payment service, and we have three subsets defined. So the first one is the baseline subset for the default version of the service that runs on staging. And then we have one subset each for the ephemeral service variants that are deployed from individual pull requests, right? As a part of the configuration entry definition, we also have the default subset specified as baseline. So what this means is by default, all the requests that are intended for the payment service are sent to the baseline subset, right? Which is the standard behavior in the staging environment that we already had. When we are registering our service instances with console, we must now remember to include the meta attribute, ephemeral, with the value set to some identifier for the pull request itself, right? So if we do this, we are sort of opting in to our service instance being classified or being put into a specific bucket that we defined earlier. So together, what happens here and what we are essentially going for is to have multiple variants of our service running alongside each other on the same environment and known to console, right? So what these variants are essentially doing is that they're serving as targets for our smart routing rules, which we're going to set up next. So the service router configuration entry, I think, is one of the most powerful features of the service mesh, because it allows us to shape the traffic within the mesh without reconfiguring individual services. For example, here you can see the service router definition for the payment service, and this should be pretty easy to follow. So you have like a matching rule against a specific HTTP header, and then you're checking if its value matches PR1234 exactly. If it does, instead of routing the request intended for the payment service to its default subset, we route it to this specific subset. If you do a quick recap of the requirements, for the two open problems that we had earlier, we have now found solutions using tools that we already had. The first being distributed tracing, and the other being the service resolver and service router configuration entries. So now if you quickly revisit our reference system, you can see that we're now setting our user intent using request headers that follow the OT-baggage convention. And because we do that, the tracing rails that we have, it's able to automatically propagate these headers to each of the services that are seen in that request path. And because we have our service resolver and service router configuration entries defined as a part of the service mesh, the requests reach the desired service versions. So now that we have all the ingredients that we need to achieve what we wanted out, that we set out to do, now let's talk about the high-level design for some automated workflows that we can have in place to unlock the power of ephemeral service deployments for our developers, right? So I feel that the pull request is a core part of the modern SDLC. So I think that's a reasonable place for us to hook into. So imagine if a new pull request is opened, or a series of commits are pushed to an existing open pull request, we might want to execute a CI recipe that looks something like this. First is we'd want to stop all the existing ephemeral service deployments, if any, related to the same PR. Then we'd want to build a new Docker image and attach a custom tag. The git commit hash would be a good candidate here. Then we deploy the ephemeral service to the same staging environment. Then we register the service instance with console. We'd want to remember to set the ephemeral meta attribute to indicate that it's an ephemeral service instance. Then we'll update the service resolver config entry for that service to add a subset for the PR if it doesn't exist already. Finally, we'll update the service router config entry to add the custom routing rule like we saw earlier, assuming it doesn't already exist for the same PR as well. And likewise, if the PR is merged or if it's closed, we might want to run a CI recipe that looks something like this. So we stop the ephemeral service deployment. We deregister the service instance from console. We update the service router config entry to remove any custom rules you would have added. And finally, we update the service resolver config entry to remove the subset that we might have added for the same PR. So now let's look at a short demo to see this in action. So imagine that this is the console server running in the staging environment for the e-commerce system backend that we saw earlier. So you have all the services running in this environment registered here. So you have a mix of the baseline services and the ephemeral services. All the ephemeral services are tagged, so you can also look them up using the tag, which is pretty useful. Note that the service resolver configuration entry is not viewable from the console UI. So to make it easier to visualize, I've just renamed the services, but the idea is the same. Now let's look at the routing configuration entry. So for the payment service, if I go to the routing config, you can see the two routing rules at play for each of the possibly open pull requests, right? And if I go to the currency service, I can see something very similar. You have an active routing rule at play here as well, where if a specific header is seen and its value matches a particular value, it will be sent to this variant of the service instead of the default variant. Now, let me quickly reset this. I think it's reset. All right, so this is so for the front-end application, I'm using this fake service web UI. It's an interesting web app that from the HashiCorp team that we can use to visualize the backend trace for requests made from this web app itself. So in this case, you can see that the request went to the API gateway from the app, then it went to the checkout service, the payment service, and the currency service. The baseline versions were used, so there's nothing fancy here. This is what you would expect for a default request made to the staging environment. Now, to use the ephemeral variants of our services instead of the baseline versions, we know that we need to send custom headers to the entry point of the system, which is the API gateway. Now, instead of doing this manually, what I'm going to be doing instead is use this browser extension that I built to do that for me. So what this browser extension does is that it intercepts all the outbound requests going from this web app, and it decorates it, or it attaches the desired request headers automatically based on my preferences that I can specify using this UI provided by the extension. So this UI uses the console API to dynamically pull information. For example, here is a list of services currently healthy and active on this environment, and I can choose from that. So let me choose the payment service. Once I choose the service, it is also automatically pulling the list of variants of the service available on the same environment for me. So this information is again coming from the console server through the API. So let me choose a particular variant and add an override. So once I've done that, let me reload the web page and see what happens. Cool. So now you can see that the request went to the API gateway and then to the checkout service, but then it eventually reached the variant of the payment service that I was interested in. So thereby, my preferences as specified in this extension's configuration were respected. Now I can probably add another service, choose its variant, add it as an override. If I reload again, and sure enough, so the request from the payment service variant was sent to the currency service variant, just like I had asked for it to do. Now, another feature I have here is to share this environment with someone else. So let me click on that. So that automatically copies a unique URL to my clipboard. Now to test that, let me reset this and reload the page. So resetting ensures that the baseline versions are used again for payment and currency. Now let me paste the URL that I had copied. So this shareable URL is nothing fancy. You have a special query parameter, and the value is base64 encoded payload with the override, ephemeral override information. So if I hit enter, now let me check again. Sure enough, as we would expect, the ephemeral variants of my service are being used, which means that the context that I specified in the URL is being read. Further, you can also see that this context has been persisted. So which means if I share such a URL with a team member, when they open it, then this context is saved on their browser. So for all the requests made from the web app from then on, this context will be automatically implicitly attached, which is very useful. So there are two interesting things here. So the first is having an internal private browser extension, helper browser extension like this is really useful because you can make all the applications on staging, all the web applications on staging, support these ephemeral backends without making any changes to each of their code bases, which is very useful from an adoption perspective. The second nice thing here is that what we are seeing through this demo is you can have you can test any combination of services from the front end, right? And then this is allowing you to build personalized views of a shared environment of potentially infinite variations, which I think is a very compelling idea. So going back to the slides, so let's talk a bit about the benefits of our approach to ephemeral environments. The first is that it's cost effective, right? Instead of provisioning full-blown environments, we are reusing staging as much as we can, and we only need to pay for the ephemeral service deployments that we make to the staging environment. So we have now unlocked parallel testing of the same system and services from a shared environment, which is very useful. Developers can now preview and test their changes before merging. That early feedback can be very valuable to them. Acceptance API tests, which were only run against staging, can now be run as a part of the CI pipeline even before merging, which is very helpful. If you're part of the developer team, improved developer velocity and experience might be an important KPI that you're optimizing for. So this can help you achieve that. If you've already invested in a service mesh, this could be one other way by which you realize value from that investment, something to consider. Having said that, there are some limitations that I want to briefly touch upon. The first is that storage resources like the database and cache servers are still shared, so which means that there are some edge cases we need to be mindful of. For example, if we ran some schema migrations as a part of our pull request and applied it to the shared database server, we must remember to roll that back if, let's say, we chose to not merge the PR and close it instead. So while this approach works very well for microservices systems where predominantly the common pattern for inter-service interactions is synchronous RPC calls. However, for asynchronous messaging patterns, this will not work because we do not have a unified control plane like we do for HTTP requests with the console service mesh. So that's it for today. I hope that you found this talk useful, and I really and I hope that I've convinced you enough to consider implementing something like this for the benefit of the backend engineers on your team. So you can find me on LinkedIn and Twitter. If you have any questions about this idea or you wish to collaborate, feel free to reach out to me. Thank you very much. I hope you enjoy the rest of the talks at HashiTalks Deploy.
Very solid segue. We'll jump on the HashiConf note a little bit later today. Right now, I just want to say I love deep technical talks that actually have a demo that works well, and then shows something that is a very real problem. This was very well done. It was so well done that I'm going to need to take a 5-minute break. I would invite all of you to continue watching, but I'm not going to miss out on 5 minutes of content, so we're all going to do a 5-minute break, and we'll see you back here. And we're back. Time flies when you're having fun. And we're going to have much more fun for the rest of the day. We've got a couple of more very cool and very interesting sessions planned for you all. If you're just joining, you are about, let me check, 3 hours late. That's okay. We won't hold that against you. Everything will be on YouTube, both for day 1 and day 2. This is important. We want you to enjoy all the ideas and learnings our speakers have shared. Just like our next speaker is going to do. Simone Bennett is going to talk about building hard stuff, building solutions with the well-architected framework for Azure, and making the hard challenge of compliance a lot easier. So with that, over to you, Simone.
Hi there, my name's Simone Bennett. I'm a principal consultant at Arcana. And before that, I worked for Microsoft and I talked about the well-architected framework all the time. So I'm here to talk about building solutions with a well-architected framework. I'm just recovering from COVID, so I hope that you'll stick with me even if I start to get a bit croaky or confused as we go through. I'm really looking forward to hearing your feedback, and feel free to reach out to me if you think there's anything I missed. I love hearing if this was useful and if you adopted any of the tools that I suggested. All right, without further ado, let's get going. So the cloud adoption framework and the well-architected framework go together. So what we're going to do at first is talk about the key principles of the well-architected framework. We'll cover off the 5 pillars: operational excellence, security, reliability, performance efficiency, and cost optimization. And we'll talk about how does a well-architected framework fit in with the cloud adoption framework, and how do we make them part of our dev process? So how do we shift what was traditionally seen as something that was done after a workload was deployed left, so it becomes part of our process every day and we build it in. And just before we get further in, all the clouds seem to have a cloud adoption and a well-architected framework, but I just want to make sure everybody's on the same page when I'm talking about them because they can be a little bit confusing sometimes. So the cloud adoption framework talks about our end-to-end cloud journey. So how do we adopt cloud? How do we plan for it? How do we build a landing zone? How do we manage and govern it long term? And then the well-architected framework, I guess, falls in that govern and manage portion of cloud adoption framework, where it's focusing on individual workloads and making sure those individual workloads are well architected. So you've got cloud adoption, which is the whole journey, and well architected, which is individual workloads. And in the cloud adoption framework, which manages your end-to-end cloud journey with opinionated cloud adoption guidance, you have landing zones. And a lot of people I show this graphic to think, oh, that's just big. I don't need anything that big. That's too complicated. And a myriad of other reasons why they think they shouldn't adopt it. But I'm trying to convince you otherwise in one slide. So when you spin up an environment, even if it's just for a demo, if you're like me, you'd be like, okay, cool. I need to deploy this environment. And then you're like, oh, I need a network. Oh, I need subnets. Oh, I need DNS. I need private endpoints. I need key vault, blah, blah, blah. And you kind of end up building this anyway, just in a less structured way. And then once you start using it, you hit some limitation, and then you need to rebuild it, and then you need to migrate it or retrofit it. And the Cloud Adoption Framework learning zones is an opinionated way to future-proof that and sort of skip that process and just make sure you have a workload based template there. Everything's in place. You can just put things into it. It will scale. It's well architected, and you shouldn't have to go back and remediate it later. So it's not well architected, but it's kind of a big part of being well architected as well. Anyway, on with the show. Well architected. So well architected is broken up into 5 pillars: cost optimization, operational excellence, performance efficiency, reliability, and security. Obviously, cost optimization, well, how do we design cost optimized workloads, right? How do we have budgets and save costs? Operational excellence, we want to design reliable, predictable, automated deployments with monitoring, with performance management, and with extensive automation and testing baked into our applications wherever it can. And we want to think about what do our pipelines look like for deploying applications? If we detect errors in production using our monitoring tools, can we just roll back? Is that problem-free? Then we have performance efficiency. What is the ability of our system to adapt to changes in load? And how do you know if that's happening? Can it scale? Things like that. Resiliency and reliability, I guess, you know, we all know what that is. Is our system able to recover from failures and continue to function? And how are we designing our environments and our applications to be highly available? And is there an active disaster recovery plan? Does your team know what to do if there's an outage? Do you know what the impact is? Things like that. And security. I mean, security is at the front of everyone's mind. We don't want to be in the news. We don't want to be the people with the breach. So we want to build security by design, and we want to make sure we can provide confidentiality, integrity, and protect against those deliberate attacks, especially the ones, you know, targeting important and confidential data. And when we look at the well-architected framework, the 5 pillars here have originated from common challenges that Microsoft customers have faced in the past using their cloud technologies. So if you think about how many customers that is, that's a lot of data that could be collected to make sure this is good advice. And even today, the customers I've worked with at Microsoft and at Arcana and other companies, these issues are not unique. Every company all the time faces these issues. So if you're facing them, you're not alone. And don't worry, there's a path forward, so we can get there together. But essentially, the well-architected framework directly addresses these issues in a structured way by breaking them down into pillars and then providing best practices guidance for each pillar that's easy to prioritize and implement. And then these are examples of some of the best practices you might find in your recommendations when you do your well-architected review. Things like designing for scale, or using DevOps, or using Azure Hybrid Benefit. So they're just some examples of what you might see when you get your recommendations. Okay, cool. So hopefully you're convinced. Hopefully you think, okay, yeah, I'm down. I don't mind well architected. You're at the talk, so you're already slightly interested. So hopefully I didn't have to convince you too hard. But you know, it seems onerous. Maybe that's why you're not doing it already. Maybe that's why it's not done very well already, because it seems quite large and hard to implement. And that's good for me, because I can help you improve. No, that's not good. I don't know why I said that. It's just, it is what it is. You're not alone. But I did really read a really good article the other day about Microsoft and how in the software development team for Skype for Web, they sort of changed the way Microsoft thought about this kind of stuff. They used to have teams to build stuff, and they used to have teams to test it, and then they used to have teams to release it, whatever. And then they decided to eliminate that us versus them dynamic, and they emphasized a unified engineering approach. And what they found was when they did that, it really resulted in improved quality, improved agility, and improved engineer satisfaction. So it really started a movement at Microsoft of integrating that testing and well-architected practice into the development process for better collaboration and better adaptability. And the proof's really in the pudding, because they went from having monthly releases where they build a thing, test it, pass it back, fix a thing, test it, pass it back and forth until it was ready to release. And then once they did this and they had that one team, it went from being, you know, irregular releases to daily releases with a really good quality product. And I think we can also bring back Skype. It was a really good product and I miss it. No Teams, no offense to Teams, it's fine. Teams is great. So what do we call that? When we build that stuff, you know, into our dev process, when we take it the closest possible to the people building and designing our workloads, and when we try to really resist tacking it on the end and then having to rework things, we call that shifting left. And when I think about shifting left, I'm asking myself, how do I build the WAF pillars into my dev process? And how do I reduce cognitive load and decision fatigue for my teams around making sure workloads are well architected? And can we make adhering well architected principles easier by changing and tweaking our code and design in the early stages of our processes, not after, when teams might resent those changes or find them to be blockers, or just, you know, really hate them because it's rework? Let's put it at the start so then there's no rework required. Also, I used Microsoft Designer to generate all these images. So some of them are a bit quirky, and I thought, you know, they're like little Easter eggs for anyone who's paying attention. So where do we start? Okay, you're sold, you're in. My suggestion would be to build a baseline with the go live assessment or the well-architected review. And when you do that, I would say do it with an open mind, because you're probably going to get a ton of recommendations, but it's a great baseline. And you can measure it and you can improve on it and you can show your improvement because it's measurable. So don't be terrified if you have a lot of recommendations there or low scores on some of the pillars. And it's also really important to understand you don't need to improve these things right now. They don't need to be all sorted straight away, but you do need to have awareness of them. You do need to know that you can be better in some places, and you need to have a process and make sure you're always improving and measuring that improvement. And I guess it's really good to make sure the business can make informed decisions about the risks of things they're not prioritizing and things that are staying in the backlog. So having that baseline and having a security score, a well-architected score, is a really good way to justify those remediation activities that are non-feature focused, and show that they're still improving your product. So if you have a secure score of 40, you know your secure score should be 70 or more. You can show we did a bunch of work. It wasn't new features, but our secure score is 70 now. So we're a lot more safe and we can give our customers a better experience. It's I like things that are measurable. Cool. So where do you do that? So go to aka.ms assessments, or the proper link is on the page there if you would like to check it out. And then you want to look for the go live well architecture review for workloads that aren't live yet. So if you're getting ready to launch something, or you're sort of mid-design deciding if you're ready to launch, the go live review is for you. If you have a workload that's in place already and has been running for a while, the well architecture review is for you. You could do both and interchangeably, but they're probably best suited to those scenarios. You fill out the questionnaire with your team, and then it will give you a CSV full of recommendations that you can prioritize and put into your backlog. And if you're in the platform team, or you build the platform as well as the workloads, and you want to check that that's all good as well, the Azure Learning Zone review checklists are an invaluable resource. Or you can do the Azure Learning Zone review in the well architected assessments page as well. But it's not necessarily well architected, but it is, if you know what I mean. So I thought it's really good to make sure people know it exists. Okay, we have a baseline. What now? So next we want to focus on how to reduce that cognitive load and decision fatigue on our teams. We want to change or tweak our code in the early stages. We want to find issues before we're finished building and have continuous feedback. And to do that and figure out the best way to attack that, let's look at each pillar in the well architected framework and how we might shift each one of those left. Whew. we're halfway through, so I hope you're sticking with me here. So we've got balancing the book's cost optimization, and it's one of the first ones I think of because it's usually really invisible to our teams. There's great tools in the portal like cost management, Azure Budgets, Azure Advisor, but a lot of the times the dev teams don't see them or they don't know they're there. And so we need to think, how can we make that stuff visible as we develop? How do we push that info to our teams instead of needing someone to go and find it? And how do we give our teams immediate feedback and visibility so they can sort of course correct as they're going and developing and making design decisions? Well, my friends, I have a really cool tool that I like in my arsenal called InfoCost. It used to be a really simple tool that you just put in a pipeline or into a VS Code extension, and it would surface the costs of your deployment in the pipeline or in the code blocks within VS Code. And it still does that, but it's I went to check the other day and it's built right out into a really thorough SaaS app now with like policy and deployment gates and a bunch of reporting. For me, I mostly just want to see it in my pipeline, right? I just want the really basic functionality there. So you can go and check it out, have a look at the VS Code extension, which is really cool, and have a look at the pipeline CLI. So you can just start to have a look. And if you find it valuable, then you could build it into your GitHub organization and have everybody using it by default. If you're not using Terraform, but you really like the idea of it, there's a similar tool called the Azure Cost Estimator, and that's for ARM. I haven't used that one because I'm Team Terraform, but whatever you use, tools like this will really help surface that cost to you right at the start. You choose a SKU, you don't realize it's going to be $6 million a month. Before you click go, you can see it right there and you can think, oh, okay, maybe I need to change my design to use a less expensive SKU. Great, so a really important part of cost management is tagging. And they provide the visibility needed for businesses to manage versus audit. And I guess that's really something that you will need to think about in your team. But I would usually suggest forcing tag compliance with Azure policy. Audit mode to say these don't have tags, but we're still going to allow you to deploy. I would suggest setting up alerting and monitoring so that the teams at least know they need to tag that stuff before deploying, and then having it on deny if not exist in prod. There's been a big debate like they'd rather get blocked in dev so they know they'll go fine in prod versus some people who want velocity in dev and then just knowing that they need to remediate that stuff for prod. So it's really up to your team. But either way, I would use Azure Policy to enforce tagging so that your cost optimization and your reporting can be as good as it can be. Other things that aren't super easy to automate into your pipeline, but still can give you really good feedback in near real time as cost management and budget alerts. So again, you can use Azure Policy. You can say if this workload doesn't have a budget and doesn't have alerts set, create them. You can set the budget amount and all the other alerting stuff in the policy. And then you could have those policy alerts sent to the people who are building the workload. Don't send them to accounting or the platform team or whatever. Send them to the team who's building this. So say when they get to 50% of the forecasted budget you've set, they get an alert and they can say, oh, okay, we had no idea that was costing that much money. And they can go and take a look at it. They might not realize they've left a database running or, I've had, people leave Synapse running all weekend and they have no idea because they don't get the alert. So they can't remediate it before it costs a ton of cash. Speaking of tons of cash, you can save tons of cash by reserving instances, and it's one of the first things usually you talk about when you do cost optimization. It is not part of your pipelines. It is not built in to WAF, but I just thought I should deviate a little and make sure reserved instances are on the front of people's minds. A lot of people I know don't buy them because they think it's just virtual machines or they think you're locked in. but you can trade reserved instances, you can change them, and you can reserve all of these things. So it's not just virtual machines. There's a ton of things in Azure that you can reserve, and you can save, around 40% on some of those workloads by reserving capacity. Things like backups, I've seen really good savings, and databases. So completely not automated, not entirely well architected, review related, but it is cost optimization related. So I wanted to make sure that I called that out. And now we will go back to our scheduled programming. The FinOps workbook. Again, it's not automated in our pipelines, but you can configure it. You can create alerts. You can automate those reporting, and it gives you all the FinOps recommendations for your environment. So if you want to be cost optimized and you want to really get into it, FinOps workbook is another great resource for you. Okie doke. I have no idea how I'm going for time, so maybe I should hustle. Okay, so our next pillar is building a solid foundation around operational excellence, and that is holistic observability and automated systems. It covered things like automated testing, deployment gates, infrastructure as code, DevOps, Jenkins, GitHub, etc., all those things. So essentially, we want to make sure we have consistent and repeatable infrastructure deployments, and your workload would be, I guess, written in code. So you might use tools like HashiTalks, Terraform, Pulumi, or Bicep, or you might use something else. Whatever it is, it doesn't matter. If it's written in code and it's repeatable and it's consistent, then it's good. And if you aren't sure what one to use, I usually opt for a cloud agnostic tool, just so that if you have third-party things like firewalls, or you have to do one thing in another cloud, you have the same code base. But again, it doesn't really matter so long as it's repeatable and it's consistent. You're onto a winner. And you say, oh, but Simone, we didn't know about this, and some of our stuff's been ClickOps, and so now we have some stuff as code and some stuff as ClickOps, and it's really hard to, build well architected into our pipelines, and it's hard to do all this stuff. That's okay. There's tools to help with that. So if you're using Terraform, AZTF export will go and import that stuff into Terraform for you en masse. You can use the import commands in Terraform also, but this definitely speeds you up. It used to be called AZ Terrify, which I really liked because I could make jokes about it being terrifying. But now they've ruined it and given it a really sensible name, so that's fine. And then there's AZOps, which does the same thing, but for ARM templates, which you can convert to Bicep really easily in VS Code. So whatever you're using, if you've got a ClickOps environment or you're picking up Brownfield, consider porting that stuff into code with one of these tools so that you can manage it going forward. Okay, so in your pipeline, you've got your infrastructure as code, and you want to make sure it's well architected. This tool is amazing. PS rule is written by a guy in Brisbane called Bertie White, and it has the entire well architected framework, and it builds it into tests and checks into your pipeline, gives you suggestions on how to fix stuff, links to them. It's a wonderful tool. It's aimed at ARM/Bicep, but you can use it with Terraform and other pipelines as well. So I would suggest, if you want to automate as much as possible of what we're talking about today, go check out PS Rule and give Bernie your feedback, or it's open source, so you can contribute if there's something you don't like. So I guess we have automation covered to some degree, right? We're doing infrastructure as code, we're using pipelines, where, whether you're using GitHub or Azure DevOps or Bitbucket or whatever you're using for your automation. They're the only two I can think of, Jenkins. But operational excellence also means your workload should be holistically observable. So monitoring is a big topic, I know. But this could be a good place to start. If you've got a platform in place and you want to monitor the platform and you don't know how to monitor it or your apps, Azure Monitor Baseline Alerts is a tool from Microsoft. It's a repo. And it has all of this monitoring that's built as Azure policy, all the PG teams, which is the product group teams that Microsoft contribute, and validate them. So they make sure that these things can monitor their products well, and they have the baseline things they think you should monitor. So if you don't know where to start and you don't know how to have observability in your workloads, The baseline alerts is there, it's policy, so it can just auto apply as you build things. You sort of set it and forget it. Excellent. And then if you are looking at your application and you're building an application or a workload and other people are going to have to monitor it, you would need something like OpenTelemetry. And Jake and my team, who loves OpenTelemetry, convinced me that it's a great idea because it allows you to instrument your software as you're building it. So it's easier to monitor and action things later. You can do things like set it up so it can monitor database queries and tell you which ones are slow, or make sure the team thinks about what needs to be monitored as they're building it and build that in. And his example was .NET. If you use .NET applications, you can pop them on Azure, you can just turn on App Insights and everything just works. And that's because the .NET team really thought about what instrumentation is required for monitoring, and they've built that into their application early. And then you as a user can just use it. So I guess it depends if you're using an application or you're building one, but there's a couple of tools there to consider when you're doing that. Yeah, so I should say, as a bit of a summary before we move on to the next pillar, to be operationally excellent, we need to automate and monitor things that we build. We need to think of ways to build that into our processes, and we need to change or tweak that code early. So for this pillar, we need to find issues before we're finished building, and we need that continuous feedback as we go. Same as all the pillars. And I promise we are nearly done. So if you're doing a well-architected review, just keep listening in the background. There'll be a quiz at the end that you need to pass before you can leave. Kidding. Okay, so I squished these next two together because in my mind, they overlap a little bit. They're about scaling your system to handle load and identifying bottlenecks and adjusting to changes in demands placed on the workload. And we want to test those changes before deploying into production and being able to respond efficiently to failures. So we've got bracing the chaos with reliability and accelerating your journey with performance efficiency. And you can see that when you look at the two things in the pillar, they kind of line up pretty well. So keeping with the theme of like, well, how do I do that? How do I care about that stuff at the beginning? How do I build that stuff into my process? How do I give that feedback about it being well architected to my teams while they're writing the code? I would say linters are an excellent start, right? So PS rule we talked about, TerraTag, TFLint or CFLint, they're excellent. You can't push your code when it's got problems with it. Security or formatting or other well-architected pillars are covered. So they're really great. There's things like Nomad or Playwright or Chaos Studio and load testing. They're services that maybe aren't built into your exact pipeline every day, but they can still be built into your process for deployment and testing and user acceptance testing. Chaos Studio especially is cool because it uses chaos engineering to help, create random failures so you can test your resilience. And I think, when stuff really goes wrong, it's always something we didn't think of. So Chaos Studio could be good there. And load testing is really good for just putting massive amounts of load on your application to test how it will go when it's live. They're the ones I really like, but if you have other ideas, please reach out and let me know so I can add them in for next time I give this talk. And then when it comes to testing and building tests into our environment, everybody seems to know that it's a really good thing to do, but lots of people aren't actually sure how to do it. And so I think Copilot would be really helpful here. I just asked Copilot, look at my Terraform repo and can you help me build some tests for this? And it wrote some blocks of code to build TF-lint into my pipeline, as well as a other bunch of tests that you could just copy and paste into your pipeline, which is really cool. So if we want to make sure our workloads are reliable and performant before we finish building them, we need to build those tests into our process. So take advantage of the tools that are out there to make that easier for you, even if they're simple tests as a start, and then you get more complex as you get more familiar. You need to apply load so you can change and tweak your code in the early stages of the design. And you need to take advantage of the tools that can automate that, like Azure Load Test. And then we need to find single points of failure, and we need to find scaling limitations before we finish building. So as we discussed earlier, we need to monitor, and act on those alerts as we build. Cool. We are getting so close to the end and I'm running out of breath. I'm not used to having no time for questions. Okay, so fortifying your castle security, it's a big one. Okay, like it is. If you're thinking about security, it's just an endless. There's so many things that could go wrong. There's so many people trying to attack you every day. But really, the main thing we need to do is have the ability to proactively secure our code right when we're creating it. So instead of it being an afterthought, it needs to be built into our process every single day. People need to be thinking about security at the front of their mind when they're working all the time. And a really good way to do that is to really have it in your face when you're pushing code, have it in your face when you're writing code, have it in your face when you're testing, all those things. Definitely make sure that remediating those vulnerabilities and finding them is not something that happens after the fact and then it has to get pushed back through as a rework. Make sure security is something we think positively about and that we build into our process just as part of our culture. And so we need to build it in, but we also need to monitor for new vulnerabilities every day. Maybe you built something that had log4j and then suddenly it's not secure when it used to be. And so that can be a lot to take on, right? There's building it in and keeping it secure as we go. And I can hear you going, oh, that seems like just a lot, right? Like I'm just doing my best. But there's some amazing tools out there now that focus on security and make that a lot easier for you and your teams. Almost every platform you look at has some sort of security built in. Like I mentioned earlier, Infocostars, HashiCorp has Vault and Sentinel. One of my favorites is GitHub Advanced Security. It just kind of automates a lot of this for you. So it just takes away the pain. Over the past year, they've released more than 70 features to improve it, which is just phenomenal amount of development there. They include software testing, supply chain security. I really like the Dependabot scans for vulnerabilities because it just creates the PR for you. So the juniors in my team just accept the PRs and off they keep going. And if I can use it, and if the juniors in the team can use it, I feel like anyone can use it, review the PRs and keep on going. You don't need to go and remediate that stuff and Google it and figure it out. I also really like the new version that has the ability to group those multiple version updates into a single pull request. So there's not as many pull requests to review. I like that it does secret scanning and then you can customize those secret scans, and also that it's free for public repositories, which is excellent. There's some preview features that I put on the slide there just for people who are interested. But one I didn't mention on the slide but should talk about is probably that you can also use it for Azure DevOps. So that's double excellent news if you're in the Azure DevOps camp, but you really want to use GitHub Advanced Security, you can. And if you're already using GitHub Advanced Security, or that's, you know, a little ways away for you, again, look to those linters. So things like PSRule, CheckGov, TFLint, or CFLint, they're going to be great just as a starting point, and you can just implement them, you know, right now, not now. You can implement them in 10 minutes when this talk is finished, but ASAP, you can just pop them in. And then, of course, those other surfaces that we talked about before will also help with your security in your code. Yeah, so revisiting this slide. So many of these tools help. They're making sure you can't even commit code that's vulnerable, and they're really good for that culture of building security at every stage of your process. Team, we made it. In summary, we have the 5 WAF pillars: operational excellence, security, reliability, performance efficiency, and cost optimization. We talked about how does the well-architected framework fit in with the cloud adoption framework? How do we set a baseline so we know how to improve? How do we build those pillars into our dev process? Or, you know, if you want to use a buzzword, how do we shift left? How do we reduce cognitive load and decision fatigue around making sure those workloads are well architected for us and for our teams? And can we make adhering to the WAF principles easier by changing and tweaking our code and design in the really early stages of our process, by providing feedback as we go through that coding and design phase, and not providing that feedback after when the teams might resent the changes because it's rework and it's a blocker? And can we baseline our well-architected status and look to see where we can improve and manage and report on that improvement using the measurable outcomes for the well-architected scores and secure scores and things like that? I fumbled over that one, sorry, fam. But anyway, we're done. So this is me. I would love your feedback. I would love to know if there's any tools I missed or stuff you do that you think works really well and that I should tell the world about next time I get the opportunity. Thanks so much for your time and the opportunity to speak at this event. It's been wonderful, and I hope you enjoyed it. Thanks.
Absolutely enjoyed that. It takes a lot of skill and a lot of understanding of not just the industry, but also the right patterns, the right strategies, and the right tools to figure out how to build a compilation like this. You know, we throw around these words a lot, like, oh, my system is secure, it's 100% reliable, it's all fully optimized. But the path towards those words and towards being able to say those words, there are a lot of hard steps. So super great overview. And I'm excited that our next talk is going to connect very, very nicely to that. You don't get operational excellence by only deploying to your cloud provider's environment, because you're going to be missing out on things. You're going to be learning about problems way too late in the chain. And the only way, traditionally speaking, you can work around that is by, duplicating your environment. Of course, your providers, your CSPs will happily have you deploy your infrastructure 2, 3, 4 times. It's good for them. But it's not always possible. If you have 20, if you have 50 developers, that's not how it works. Our next speaker is going to be talking about local stack and a way of testing Terraform locally using that. It's over to you, Adefemi.
Hi, everyone. My name is Adefemi Michael. I'm a DevOps engineer at Swisscom. For my topic today, I will be speaking on testing with local stack on Terraform. I'll be giving you a walkthrough on what led me to this tool, and then I will also be discussing about how I use this tool day to day, and also some couple of funny stories as well in between. So yeah, let's start with the highlights. For my table of contents, I have not so much. Of course, I'll introduce you guys to Terraform. I'll discuss what local stack is, and also why local stack, why is it useful? And then for a quick one, I'll definitely do a demo of how to use local stack, and do a quick demo of what I do with local stack using some couple of Terraform configuration, and then also how to set it up as well. So introduction to Terraform, right? Terraform right now shouldn't be like a less popular tool, especially in the infrastructure as code world. And why did I say this? Because for me personally, I think it's the most powerful tool out today, especially when it comes to infrastructure as code. One of them is because it is cloud agnostic, in the sense that it does not matter the cloud provider. Terraform works for it. There's definitely some sort of Terraform configuration that is available on Terraform docs, HashiTalks documentation for Terraform that works for it. So talk about AWS, GCP, talk about Azure, talk about DigitalOcean, talk about Kubernetes. Everything is up there in HashiTalks Terraform documentation. So, like I said, Terraform is an open source infrastructure as code software tool. Yeah, and it's developed by HashiTalks. So basically, the whole concept is write once, run a lot of time, and then Terraform, unlike other languages, it uses something called declarative configuration language, in the sense that Terraform config itself is declarative. Like I said, you can use this to describe infrastructures, create infrastructure on your cloud provider, regardless of the cloud provider. Yeah, that's about it for Terraform. And now I want to look at what is local stack, right? Which is the big giant in the house. So a quick history of how I discovered the local stack. For the company I work for right now, which is Swisscom, I was given a task one time regarding building up some sort of configuration. And I started thinking, how do I test this configuration locally? This time, I knew I don't want to create a new account on AWS, which I could do using get a new card and create a new account and then just start using it. But I could remember well in college that AWS actually put me in debt, which is quite funny because yeah, I have these gifts that shows that. So I could remember why in college AWS put me in debt. So I started looking at how do I get like something that works locally and I can use to deploy resources. Then comes local stack. So local stack is an open source project that provides a local, more or less like creates a local AWS hub stack for you on development, and most of the time is used for testing before you push your code to production or whatever. So it depends on how local stack, how you set it up. I will also show you like how to set it up or how I set it up and how you can set it up as well. And you might be wondering, well, why do I need this? You're right. Like I could easily just, connect to my AWS account and just use this, or connect to my Azure account or whatever and just use this. Why do I need this? One, cost effective. So with local stack, you don't have to worry about cost, right? The only cost you have to worry about is your CPU because it is local to your system. Also faster feedback. And what do I mean by faster feedback? When you write your configuration, most of the time, you open a pull request as a developer, right? You open a pull request, someone reviews it, they confirm your configuration. You might attach some sort of screenshots to your pull request to show that, oh yeah, it is working fine. But how about if I can test it locally on my end, test it in a particular environment or with a particular account, and then see what I'm testing before I say, okay, let me try this on staging, or let me try this in development or whatever. Also improve testing. Imagine if you're making some sort of change, maybe you're writing some sort of Lambda, and then you want to just quickly test the Lambda, see the output. You don't want to go in the loop of you running Terraform apply, deploying to AWS or AWS, for instance. I'll be mentioning AWS because I've used this with AWS a lot. So deploying to AWS, you don't want to wait for the test to pass and then you seeing the output. Everything can be computed right there in your local environment. Also reduce complexity. You don't have to think about the overhead of setting this up. So I'll give a quick demo of how I use local stack. This is just a simple demo, and I'll be pushing this code to GitHub. So definitely, I will share the link as well to how to access this code on GitHub, so you can set it up locally in your environment. I've added some sort of little bit of README in the file to aid you in setting it up. So yeah, let's get ready to go to space. Let me increase this a bit. So, like I said, I'm just doing the simple stuff. So I have a Lambda function, and what it's just doing is just printing out, oh, this Lambda was successfully triggered, and also welcoming you guys to HashiTalks deploy. I have a main.tf, something simple, no crazy stuff. So I have a resource that is created the Lambda function, right? And in this place, I'm passing in the handler. The source code hash is my zip file. What else? The file name is source.zip. Then it gets deflated in my Lambda. What else? I'm creating an S3 bucket. I'm calling the S3 bucket test bucket. is 070. Of course, I'm making my ACL public read. Of course, you can make it private read, but then you have to go through the override of making some sort of configuration to make sure the bucket is readable the bucket is readable by your Lambda. I have an S3 bucket notification, and this is just going to trigger the Lambda when I create a file or push a file to my S3 bucket, right? I have the Lambda permission that just says, okay, allow the Lambda to be invoked by S3, basically. So I'm creating a CloudWatch log group. And why do I need this? Because I want to see my logs. I want to see this print statement that I'm passing in my logs. What else? I'm creating a role. Of course, this works, but I have to remove it so I can do some sort of code separation between the policy for the role policy and whatever policy I need to create. Yeah, so I'm creating a role. Of course, this role will actually be assumed by Lambda, so something simple. Passing the role policy as well, which is just going to read from this resource and allow all action, basically. And in this place, I'm creating an action for my also adding an action for the IAM policy. And what this is just going to do is going to allow us to create log stream, because I need log stream, and I also need to put the log event into my logs. The last part, I'm just attaching my role, which I created, to the policy, to this login policy for the Lambda function, basically. So local stack. Now that is for the Terraform part. For the local stack part, so with local stack, you can run it in a couple of ways. You can either run it in Docker Compose, you can run it in Docker directly, or you can install local stack locally in your environment and then run it that way. But for this demo, very quickly. So yeah, and you can visit local stack quite direct, localstack.cloud. And in their docs, getting started, installation. So in their docs, you can see you can install local stack CLI, and they also have alternatives. So you can do install the local stack desktop, the Docker extension, the Docker Compose, which is the one I'm using. You can install it with Docker. If you are conversant with the Kubernetes environment, you can also install it via mchat. But for me, I'm just going to install this via Docker Compose, and then I'll show you some of the configurations that I'm passing in the Docker Compose. So back to this place. So it's just something simple, right? I know my image is local stack. Local stack is actually defined here. So I'm just doing a copy and paste of what is here actually into my Docker Compose file, and that's just it. So I'm running this debug level just so I can see my output, connecting the Docker host to the container, basically. And then lastly, I'm setting some volumes in which local stack will be run. So now let's test. So because I've, of course, run this before, so my Docker Compose up will be quite direct. So of course, as you can see, it's saying local stack version 3.0.2, which I think is the latest, and the container ID and some weird outputs. But the interesting thing about this is you can also visit this URL locally on your environment, which I will show you as well. So let's go through the steps. First, we have this. Okay, let me delete this file so that we can start from Terraform init, and then we don't have to do this. So, of course, with Terraform, right, you first want to initialize your Terraform configurations using Terraform init, right? And before that, you might need to export your access key ID, your secret. As you can see, I'm just passing a random secret and a random access key ID. So this is allowed. Just random values, we don't care. initialize Terraform configurations. Yep. So this one Terraform init is going to initialize Terraform. The only thing I'm doing here, or that is needed here, is the HashiCopy WS. And I think that's just it. So this should be really, really fast. Yeah, that's done. And then I'm going to do Terraform plan. Don't forget, I've exported my my access key and my secret key and my region. And as you can see, yeah, it's just a random generated string. Terraform plan, which should show us what is about to be deployed, of course. Should be quick. Let's hope so. Yeah. So this shows us that, yeah, we are going to deploy. So this shows us that we are going to deploy CloudWatch logo policy function. Of course, we need that. IAM role, of course. Let's see, role policy, of course. Attachment, of course. The Lambda function, of course. Create the source code as false. Okay, good. Lambda permission, of course, the S3 bucket, of course, and the bucket name, 070, of course, random. What else are we deploying? Some additional information here. The bucket ACL, not really needed because we just passed that the ACL should be public, so cool. Notification, what we trigger the Lambda, basically. And if you look at the output here, it's saying, oh, the account ID is not found for that provider. We don't care because we know we are not deploying to a particular AWS account. So this is just running locally, so we don't care about this. And then I'll run a Terraform apply. Apply these changes. And this should also be quick. And when I apply the changes, let's look at this place because I've put auto approve here. In the output of my Docker Composer, you will see some sort of like out because I pass in this debug, so I can see some sort of output here. So it's creating policy, good. Create rule, good. Get rule, good. Get policy, good. Showing me S3 bucket, or you can read S3 bucket. S3 bucket policy. So I didn't pass this, so that's why I say no such bucket policy. I didn't set up cause because I really don't need it to test my Lambda. So I didn't set up bucket website. I don't need this. I don't need all this stuff that is showing 404 because I didn't set them up, obviously. And bucket tagging, of course, I didn't set it up as well. So good. Yeah, all this looks good. Added the permission. Okay, all this looks good. Let's go back to our Terraform apply. Okay, so apply complete. Like I said, we don't care about this. Yeah, because we are just doing this locally. And if you check my provider.tf, I've passed in some, what's it called, some access key, secret key. Actually, I don't need to do the export because I've passed it in here. And I passed in some endpoints. Honestly, the only endpoints I need is for CloudWatch logs because because I'm using all this in my code. That's why I'm passing in the endpoint here. So I'm passing in the endpoint for CloudWatch because I know I'm using CloudWatch logs, IAM, Lambda, S3, and STS. This is also available in local stack documentation. And also I'll show you what are the current service that they have available that you can use out of the box. Okay, so now this is done. Let's go back to the README. Let's see if I can make this good. Nope. Yeah. So now we've done Terraform apply, right? Let's do something interesting. Yeah. So we've done Terraform apply. Let's copy a file to S3 bucket. So I have this file here called file.md. So let's copy that to S3 bucket. And if you notice, I'm passing in endpoint URL, right? And I'm pointing to localhost 4566 because the port I'm exposing is 4566. And I'm passing into this bucket. And as you can see, upload complete. Let's list the files in that bucket to see what we have there. As you can see, file.md is present. Okay, so the last part, which I'll show, is to check the logs, our CloudWatch log. So first, I need the log stream name. So I can just do this and to get the log stream name. So the log stream name is, this is what I need. And then I can upload my README here to use this log stream. I've already written a query that allows me to pass the log stream, the content of the log stream, to a file called log.json. So I'll just copy and paste this query. Of course, it's going to be in the README, in what I'll push to the GitHub repository. And then I can run this, and this is going to create a log.json file for me here. And if you look at my log.json, right, this is the logs of the, this is cloud.logs. You will see it as a start request, just normal cloud.logs. And then for Lambda, and then you can see Lambda successfully triggered welcome to HashiTalks, which was what we defined here. Of course, if you want to make your Lambda complicated, you can make it complicated, adding more functionalities, depending on what you want to do. You can do that with the Lambda. Last but not least, which I promised I was going to share, was I've seen sometimes people mistakenly, and of course you are also seeing the output here as well. You are seeing the output of everything that we are running. You can see the output here. Last but not least, like I was saying, I've seen people mistakenly close the tab that is running the Docker Compose. So if you close this tab, it deletes the whole thing, so you don't have access to this endpoint, to this bucket, and then you don't have access to the resources that you've created. So if you don't want to close this, of course, you can run, if you don't want to mistakenly close this, you can run Docker Compose in detach mode, which is just passing the -d flag here. And then you have Docker Compose running in detach mode. I promised I was going to show some of the services that they offer, or that they are currently allowed in AWS. So when we go to user guide, local AWS service. So all the service that have about 5 stars, or 1, 2, 3, 4, 5 stars, means that they are fully supported. This one means that they are partially supported and whatnot. So you get the gist. So from here, you can see the support ACM, the support Amplify, the support API Gateway, and they will also tell you what they support in that particular service. For me, you will see I'm using, they also support Athena, which is interesting. But also notice that some of the service has something called Pro at the front, which means because local stack has 2 versions, they have the community version, which is what I'm using. They also have the Pro version, which is the paid version. And PS, I don't work for local stack, but I just enjoy their tool, which is why I'm talking about it. So I'm not trying to push local stack to you. But they will have the Pro version and the community version. And the Pro version, you get, of course, much more enticing thing. The community version, you get enticing stuff, maybe less, but that's fine. For me, I'm using S3, which is community version. Yeah. So for me, I'm using S3, which is the community version. So we are all good. If what you're working on doesn't require the Pro version, then yeah, I think the community version is much more than enough. And I think there's also a way where you can actually use the Pro version. I don't know. But yeah, that's what they offer. These are all the tools they offer. They have some sort of integrations as well with all these tools. You can use their, they have integration with running it in running their, configuring all their environments in the command line. So yeah, it's quite a powerful tool to use. Honestly, for me, it's really, really nice to use, especially given the fact that I don't want to always create something on AWS to make it work or to see it work. So this is quite direct and just cutting off straight to what you need to do. Going back to our presentation. So yeah, we have that deployed, and like I said, all good. Everything is deployed fine. We were able to what's it called? Push a file to to the S3 bucket. We're able to get the logs, see the output of the logs. Yeah, which is more or less what is needed in local stack for my demo. So overall, what did we learn? Two things. We learned that one, with local stack, you can test your Terraform configurations, right, with the community version. And of course, if you're subscribed, you can test it with the pro version. We learned that you don't have to be in debt when you are running resources on AWS. So which include cost savings, like I said. With this, you can provide faster feedback to someone. If you're doing peer programming in your office, you can also use this to provide faster feedback. You don't have to wait for the person to deploy before you see the changes or whatnot. This can be seen live. This also helps with testing as well. So instead of writing code, pushing it, writing code, applying the changes directly to your account, you can write and apply the changes locally. So it's portable in the sense that, I mean, I can just literally send this code to another person and then they run the code, they get the same output because it just has to be Docker Compose up and then that's just it. Also, like I said, complexity to just reduce overhead in general. So with that, I think that comes to the end of my talk. So yeah, thank you so much for listening. Let me know if you have any questions. I'll be in the chat looking out for questions. Thank you.
This is beautiful. Local stack has come such a far way since I've last used it. This is absolutely amazing. If you happen to be a Nomad user and you're thinking, what could I be doing the next few weeks while work is very slow? I would totally love if you could build a Nomad pack for local stack so I could use it that way. I'll send you some stickers. With that, it's feeling kind of lonely in here. Wonder, Jasmine, can we bring somebody in here? I don't want to be alone. Beautiful. Adriana, hello.
Hello.
This is amazing.
Nice to be here. Very excited.
This is amazing. This never works out. I wonder if I could also order coffee. We'll talk about coffee later. Hey, welcome to HashiTalks Deploy.
Thank you.
And thank you for taking over emceeing duties.
No worries. I'm excited. It's my first MC gig, so y'all be kind.
People here have been very nice. We've got great questions, great speakers. This event runs itself. The only thing you're required to do as an MC, I was told that, is to have audio issues at least once during the event.
Ah, okay.
This is key. For the people that don't know you, what do you do and why? What's your motivation to do what you're doing?
Yeah, so my name is Adriana Vilela. I am a senior developer advocate at ServiceNow Cloud Observability, formerly known as Lightstep. So I spend most of my time talking about observability and reliability and spend a lot of time working in OpenTelemetry. And I dabble in the Hashi things as well. My previous role had me manage two teams, and one of them was a platform team that ran a Hashi stack, including Nomad. So, and that's how I became a HashiCorp ambassador. This is my second year as a HashiCorp ambassador, and I'm also a CNCF ambassador. So I've got, I think, all the world's covered. So yeah, I love solving difficult problems and writing about them. Blogging is my jam. Tech blogging is my thing. So yeah. And I've got a podcast called Geeking Out.
We should definitely highlight that later because we want people to listen to that. There's a lot of great content in there. Before we jump to that, who's our next speaker?
Ooh, our next speaker is Madhu Kumar Yaluri, who is an AWS hero and solution design architect at Deutsche Bank, who will give us a talk on how you can leverage Terraform to automate and streamline EKS cluster provisioning, taking the guesswork out of the process in his talk entitled Simplify EKS Deployment with Terraform, Unlock the Power of Automation. Very excited to hear about this.
Love it. Let's see it.
Guys, so We're going to learn about how we're going to create an EKS cluster using Terraform in a fully automated way, including all the landing zone resources that it requires to run. So this is my GitHub repo where all the code is. So basically, I've forked it from HashiTalks. This is the guidelines which we're going to follow and verify. And this is my personal account where we're going to, as you can see, it's all empty, no clusters. We're going to go verify, create the cluster and verify, what the Terraform creates and basically validate. I just want to quickly share you before we do that. Make sure, there's an empty cluster here. So, I mean, we don't have any clusters here. Let's quickly check the network components. You can see here, so it should be only a default VPC and without anything else. We'll give it a second. Right. So we can also check the range. Taking a little longer than usual. Just give it a second, please. Right. There you go. So basically what we're going to do, we will execute this Terraform script to create. So these are the prerequisites which I've already installed on my terminal. And this everything will be again, shaded up for the demo. So don't worry about it. So this is what we're going to use. And this is basically a high level architecture where how we're going to create the cluster. And yeah. So any adjustments, we don't use Terraform Cloud for this demo, we use basically open source version of it. So I will show you when we're doing it. So there you go. So this is the default one, so which we will not use. And the Terraform will create another VPC, dedicated subnets for EKS cluster, and then basically we host the cluster in that new VPC. So there will be like 3 private subnets and 3 public. And then we're going to host EKS cluster. Right, so now let's go also to the IAM just to make sure we don't have any roles apart from the default ones or service roles. So so there's no clusters. There's just the default VPCs, nothing else. And then the IAM, I would expect only the service IAM roles and no customized roles. And we're going to kick off in our terminal in a bit. Okay, so let's go to roles. So here we go. So it's all service roles, EKS, no groups, auto scaling, So there's no basically custom roles that exist here, as you can see. But once we run the Terraform, it creates some IAM roles which are required, and a new VPC and subnets, and brand new cluster running here. All right. As that said, so now let's go back to our terminal. So I will quickly, let me do a git pull. So there you go, it's all updated. And this is basically a clone from my repository. And all we need to do is you do a Terraform init to download all the required Terraform modules before we run. I'll just show you, it should already have the required modules, but I would like to run and show you. So what happens in the init process is basically it runs the required modules and save it locally. The error message you're seeing is because it's expecting a cloud organization, but we're not using Terraform Cloud. We use Terraform Open Source, so for that we need to edit this file. So let's comment out this section here. Like that. So basically we don't use Terraform Cloud, we use open source and with AWS provider. So we're going to create that in AWS. Okay, so that should fix that. So let's do an init again, just to make sure all the tracking modules are downloaded locally, and yeah. So now it's trying to initialize the provider plugins. It's successfully initialized. So now what we're going to do, we do a quick Terraform Cloud to see what resources Terraform creates, basically. So, and then we will do apply to actually create that. So Terraform Cloud basically doesn't create any resources in our AWS account. It just show you what a resources that is going to create, and then based on your input, when you say Terraform apply, and then it creates the actual resources. So this is just basically going through all your Terraform modules, and it's telling you what. So as you can see at the end, so 55 to add, nothing to change, nothing to destroy, because it's just a new deployment. So as you can clearly see, so you can you have to run Terraform apply to actually create the resources. So that's what we're going to do now. So Terraform apply. Right, so what this is going to do, it creates a landing zone for the EKS cluster, like eVPC, subnet, this network components, and required privileges to run the EKS cluster, and then it spin up the EKS cluster in that newly created VPC. So let's give it a minute, it just picks up, there you go. So once you have this, when you apply, you need to confirm it by saying, yes, I would like to perform the actions above and create those new resources in my AWS account. Then now this connects to my AWS account from my laptop, and it's basically creating required modules that are required for creating a EKS cluster. So behind the scenes, we can just quickly check what's happening. So just refresh the EKS cluster. You can also see the output, as you can see here. So creation, ingress nodes, creating some rules, security groups, creating some route tables, subnets, yeah, stuff like that. So let's go to the landing zone. So here, if I quickly refresh, you should see new VPC. There you go, education VPC. And if you go into subnets, you should also able to see some newly created private and public subnets. There you go. So 3 public and 3 private. This is where we're going to create our EKS cluster. If we quickly check here, you should also be able to see some new rows created. But here you can also see security groups which are required for the EKS cluster. You can also follow the creating a NAT gateway, doing some association with the route table. It's finished creating the subnets as we have seen it, and now it's creating the NAT gateway to the cluster. So here, let's see. So here you go. So that's our security groups. EKS cluster S3 education. So these are all newly created security groups. And if you see also some route tables, you should see some of them. There you go. So, okay, 1 second. Yeah, these two. So there's another public and private route tables that we manage, and it associated the newly created subnets there. And if you go on the NAT, you should also be seeing NAT gateway. There you go. So it's pending. It's still in progress. So yeah, so it's behind the scenes, it's all getting created. You can see now newly created roles. Education KS, that's for the service. Because as you're not using the default one, so it's going to be creating a new node group EKS for the roles. And if you go in the cluster, if you refresh quickly, I think it will be in progress. Yeah, there you go. So it's creating. Let's go back to console and check the status. It will take for sure 8-10 minutes to create the cluster with all the resources. But I just want to quickly show you some components here. So when it's all created, you get all the values here. So if you have 7 point, certificate authority and stuff like that. So as you can see here, so the newly created IAM role is associated to the cluster. But again, all these values will be populated as it creates and stuff. So we're not running any pods. When it finished creating the node groups, you will see here the node groups up and running here. As you can see here, that's our newly created VPC, and these are our subnets, and this is our security group, newly created one. So we're using public and private endpoint access in this example. So yeah, and we're using a Kubernetes version 1.24. So let's get back to the console and see. Yeah, it's in the process of creating all those aspects. So I want to quickly see we check the EC2 as well. Let's check the EC2. Okay. Here I'm basically checking if they've created the node groups required instances. Oh, it will be in the process, it won't be ready, but let's have a look. We know it's all done here. We know we created the IAM roles and we're using them. So just see, the whole reason for this demo is to show you the power of automation. Yeah. So this is basically out of the box scripts which I'm trying to execute to create an EKS cluster in a completely new, in any AWS account, without any restriction. So this is the power of automation. Yeah. So Terraform really is very useful as an infrastructure as a code, and to create your resources, manage your resources on AWS cloud. This is really, cool. So if you go instances, I think it will be in the process of creating them. So nothing is running at the moment. So if I just clear the filter running, you might see some started creating, or okay, so it will start slowly. So we will see some EC2 instances here once it's finished in node group. So here, as you can see, it's still creating a cluster components and associating as we execute. Yeah, so this will be refreshed and added with new EC2 worker nodes attached to it. Let's go back here. So that one is creating just to show you what it did, so far. So it also created a CloudWatch log group actually. That's interesting because it all the control plane also default goes to CloudWatch, and then in this CloudWatch log group, I will show you. You can open a cluster console and check what the log group is. EKS node group, basically creating an IAM role for that. We have seen these two roles. IAM policy, create a policy, so make sure maybe it has a least privilege attached to it or required privilege to it. And it also created a KNS key, which we use it for encryption for the rest. We have a node group IAM policy attached to it. VPC, cloud tables, subnets, public and private, updating the route tables, associating them to the subnets, security groups. It also has created some rules. And then it's also attached to its policy. So the roles, and it's created a NAT gateway for the outbound internet traffic, just to make sure it's secure. And now it's creating a cluster and associating all that components. So let's go back here again and just see what's going on. So let's see what's the node group is like, log group is in CloudWatch. So here is where you basically see all your control plane logs by default, and you can use either Prometheus or Grafana to collect the metrics for your control plane, API calls, and then also create some dashboard. And all the logging can also be exported to OpenSearch, and then you can basically search for any errors or anything for your for the development purposes. You can use OpenSearch as well. But the default is CloudWatch. So let's see what log group is created and how it looks. Just gonna quick refresh. It's still creating all the cluster components. So it takes a little bit time because behind the scenes, what it does is it creates an AWS environment instance which is not visible to us. It deploy all the Kubernetes this version and make our that server API endpoint available for us. So yeah, quite a work behind the scenes. So if you consider all that, it's still, to be honest, fast enough, I would say. Okay, let's go to CloudWatch. Go to the logs. Go to log groups, and here I should be able to see the newly created log group for your EKS cluster. It's loading, 1 second. Okay, loading log groups. There you go. So AWS EKS education EKS cluster. So any of those logging that our cluster generates, it's basically creates a log stream like this. So Cube API, for API server, authenticator, so all the logs will be, we should be able to see here what's going on in the background. Should be able to search, create some alerts, anything on top of this. So while it's loading, let's see what's the status. Nearly 10 minutes. Should be nearly complete now. So as you can see here, you can see all the events Cube API server generates, and you should also be able to troubleshoot if something goes wrong. So this is the place where basically you check the control plane logs. And if you go back, you also have a log stream for authenticator. So any type of authentication issues, this is where you should be able to check out. So on the IAM roles, all those stuff like that. So this is where you basically can see what's going on. Cool. So we captured all the logs, the log groups to our cluster. We still creating the cluster. The landing zone is created where we're going to run the cluster. We have dedicated roles which we created for our cluster with the specific policies attached to it. Just want to quickly check the policy to make sure if there is any least privilege principle or okay. So someone like service, these are AWS managed policies or EKS cluster policy and resource. So AWS already customized and made it available for us. And this policy is basically what our Terraform created. I just want to see what that inline policy does. Additional to our AWS managed policies. Right, let's quickly go back to our cluster again and refresh. yeah, I can see the server API available here. Let's go back to the resources, and you can quickly check the resources. As you can see, yeah, so proxy is running, Kubernetes, AWS nodes, so which means if you go to compute, you will see your, yeah, there you go, CPU small, you have 3 worker nodes, and you have 2 notebooks associated to it. So if I go to my EC view, I should be able to see my newly running worker nodes here. There you go. So we have our worker nodes up and running. And this you can control by your desired input to inputs to the notebook creation. Yeah, so you can basically customize how many worker nodes you need and how you want to scale up using auto scaling group. It should also create an auto scaling group, and it associates to that our notebook. That's how it basically scale up, scale in, depending on the resource utilization. I think, yeah, I quickly would like to show you what this, basically it created an extra inline policy to create a permission to create a log group and then deny everything else. So that's just implementing a least privilege principle. So that's good to know. So basically it's tightening up the security where what is required and limit the resources or permissions to yeah, to the resources what is needed to be created. Yeah. So quickly out of scaling group here, as you can see. So our Terraform script also created 2 auto scaling groups and associated to our 2 node groups. And yeah, so it has 2 instances, one, and because our desired capacity is 1. So this basically reflects how many nodes you would like to run at any given point of time, and minimum at this and max 3. So it means if your web resources are going up, you will basically spin up another instance here, and here we are saying it does the same. And we are scaling across 3 AVs here, as you can see. So yeah, if you quickly go to Terraform output, as you can clearly see, so all our resources are created. And it also gives you, there you go, output values. Okay, this is your endpoint for your cluster, that's your cluster name, that's your security group, and which region you're running your cluster on. So it's pretty neat, guys. Yeah. So using Terraform to create such a big Kubernetes cluster on AWS with all these components, notebooks, upscaling, IAM, security policies, your landing zone. It's yeah, it just and you can also adjust all these variables, yeah, so into your desired capacity, and you can also adjust some of the components how you would like to host as well. Yeah, by editing your Terraform files, variable files, or something like that. But yeah, this is pretty neat. Your cluster is up and running. It took a little bit while, but I think it did the job. It's basically showing here you have a new Kubernetes version, and you can plan an upgrade or something. So new Kubernetes version available, and yeah, so 1.25. But this is pretty cool. So here you can in the EKS console plane you can see what your resource capacity. So this is newly enhanced one, not newly, but yeah, they enhanced a little bit than since they launched. So all the ports you couldn't able to see in the past, and now you can see all the node ones, your compute, your basically network infrastructure, any add-ons you have, authentication. This basically you can also provide an provide you see identity providers and external ones that you have. Login, so we turned on the API server or even authenticator, so these logs you will be able to see in the CloudWatch. You can also turn on controller and scheduler as well, so they will create an extra log streams for them. Yeah, so this is how the power of Terraform in an automated way to create your EKS cluster on AWS. Okay, but how do we turn it down, Mother? Because I don't want to and get the cost for this POC. So what do you do? So basically you do a Terraform destroy and you enter. I mean, it basically gives you a warning, so it does straight away tear your cluster apart. It just analyzes your state file, what it created, and it gives you an output similar to that. Okay, you're going to destroy 55 resources, what I just created, and you want me to go ahead. And then once you say yes, your cluster, your infrastructure components here, landing zone, IAM roles, subnet, everything will be deleted, and including server stuff as well. So let's go ahead and see. So it's basically what it's doing in the background is it's checking your state file for what the resources it created in the past, and there you go. So 0 to add, 0 to change, 55 to destroy. So I say yes, please destroy, and because I don't need it. And now it connects to my API account, it rip off everything, and it's going to delete every single thing it's created. So let's go to, let's see the state of the cluster while we're running it. So it basically will say, instead of active, it should say deleting cluster or deleting. So 1 second, let's see, refresh. Maybe it started with something else. Okay, so let's go to the VPC. So this will be the last one to delete because the cluster is still running, so you can't just delete if you have an existing resources. So the state of the things will definitely change. So let's go back and see the output. Yeah, so as you can see, it's still destroying the node groups, destroying the route tables. Yeah, they're all in the process actually, so it's not completed yet. Behind the scenes, it's kicked off the process. So here, if I refresh, still active, but yeah, you see it's staying updating the capacity, but it's deleting it. You know, same. If I go for the subnet, this will be the last ones to clear off. So we have to refresh. It's doing the network components first, so then it will come. So let's do gateway created. Let's see. There you go. Let's delete it. And let's check the status again. Refresh. And let's do it here. Let's do another refresh here. So as you can see, the set capacity is 0. So now if I go to EC2, it should shut down my node worker nodes. So let's have a look. It's a little slow for some reason, but yeah. It should also delete this log groups. But maybe at the end, it's starting with the infrastructure component, so that gateway is deleted. And at the end, it will delete the VPC as well. Once all the resources and the VPC are cleared up, it should delete all this newly created IAM roles as well. Let's go back and check what's going on. Yeah, it's doing the EC2 instances at the moment, not good. So if I go to EC2, you will see it shutting down or it's already terminated or something like that. So let's go here. Refresh. It's still showing active, but yeah, we know that it is deleting everything in the background. So yeah, you can see all zeros. That means your instances should be in the state of terminated or basically stopped. So there are no running instances. So if I clear this filter, you will see 3 instances with a terminated state or something. There you go. So we have 3 instances with terminated. So all the instances are terminated. Let's go back. You can see log group is inactive, so it's basically deleting it. 3 pieces at the end. It is going to come in a bit. So let's refresh the cluster again. So let's go back to the outputs. Let's see what's doing. Yeah. So I terminate all the instances. It's destroying the node groups, and it's now destroying the cluster. So you should see your cluster is status as deleting or it disappears. So here, while we're here, I would like to refresh and see if yeah, it removed the auto-scaling groups as well from here. Deleted. The instances will also be disappeared slowly or it's terminated. Your log group is inactive. And your VPC will also disappear. So let's go here. Yeah, you see the status now is deleting. So cluster is still deleting. It takes some time. Let's go to roles. Let's see if it's deleted roles. Yeah, I can see two are gone. So there's one more. It's deleting. So yeah, so it's pretty easy to create a case cluster using Terraform on AWS using this Terraform script, which I'll share in my GitLab repo. And you have this one, and you have step-by-step instructions on how you basically would like to configure and run this here as well. But yeah, again, you can customize depending on your needs. Yeah. So it's pretty clean, pretty neat. If you want to learn how you want to migrate your Kubernetes clusters to AWS, run some pods, yeah, do some POC. This is a good start. Where you don't have to invest too much time creating your own scripts and running, so just basically clone your Git repo and then just kick off, to be honest. All you need is an AWS account. So here, let's go. Security groups we have also seen, right? So let's see if that's security groups also gone. All terminated. Refresh, so you can see it's inactive. Yeah, all the log groups are gone. The VPC will be gone after it completely destroyed. Yeah, it's gone. So our VPC landing zone is gone. So if you see, that's the default VPC which we have before. So that's, yeah, all the subnets which we created are gone. So that means your cluster should also be gone. That's it. No cluster found. If you go back to clusters, and your cluster is gone. So that's it, guys. Yeah, so it's pretty neat. I created the landing zone where I want to run my EKS cluster. We created the EKS cluster, we verified all the components, and we destroyed every single component we created using Terraform destroy. And you don't have any charges after this, so it's all gone. So the security gates which we created, it's also cleared up. And yeah, nice and easy. Thanks, guys. That's all I would like to show you.
All right. Thank you, Madhu. Provisioning Kubernetes clusters is definitely not for the faint of heart. Been there, done that. So having tooling and processes in place to simplify things helps us so much. I want to encourage folks who are on YouTube to post those questions in the chat. Don't be shy. Keep sharing your thoughts and comments on the talk. We'd love to hear what you think. Our next speaker is David Min with his talk, Generative AI Terraform Companion POC. An incredibly exciting topic, which is using generative AI on AWS. I am super excited to hear about this. This sounds like such a cool topic.
Generative AI, the open source world is rapidly evolving, bringing powerful new technologies within reach of everyone. In this HashiTalk, we'll explore an exciting concept, RAG in a box, and see how we can build Terraform Companion POC proof of concept using open source models. Hi everyone, my name is David Min, Senior Partner Success Solutions Architect at AWS. Let's start with a quick demo to get familiar with open source large language model and take a look at Terraform Companion POC app with RAG turned on. Switching screen to demo here with Streamlit, let's take a look at what the language models can do as far as some of the pre-trained knowledge. We're gonna use prompting here. Let's take a look at a few questions. What is HashiTalk? Okay, so looks like the pre-trained model already has knowledge about HashiTalk. Let's take a look at a few additional questions. What is HashiConf? Okay, so the result shows us that even the small open source models like 7B models has knowledge about HashiConf. What about Terraform? Right, in this case, Terraform, here's a quick description, how we can learn what Terraform is and quick description of what it is. Let's see if language model can teach us how to get started with Terraform. All right, so showing us the step-by-step approach, Terraform plan, apply, and destroy. That's interesting. Now, going back here, and looks like the link that language model provided, it redirects us to the download page. So looks like we just learned through the LLM how to get started with Terraform, and that looks good. Now, if I want to ask additional question about more complicated task, can the LLM perform? So let's ask a question about write a social media post on how to get started. Let's get a little creative here and let's see what LLM can help us. Okay, so it summarizes the steps in a very simple, easy to understand format. And then I can take this to social media to increase the awareness of Terraform. Now, let's take one step further. Perhaps we can ask language model to write a blog on this topic, how to get started with Terraform. All right, so we are looking at language model generating large context based on the context that it used earlier and be able to create a blog, which gives us a baseline for us to work with. And then we can sort of find the use case to post the blog to increase the awareness. And then the next question was about Terraform code for VPC. And looks like pre-trained models already have knowledge about Terraform, some of the AWS constructs, and VPC at this point. And that's very interesting. Now, let's compare that with our custom-made Terraform companion, and it is using the top 7 most downloaded AWS modules for Terraform. The intention was to create the based on the standard template that was published and be able to generate the same consistent output for users. Now, in this case, Terraform code for VPC generated consistent output. Let's take a look at Terraform code for DB, in this case, RDS instance. And it's going through the entire section of the code block that we generated from the data set. Now move on to Terraform code for EKS. That's more complicated due to the fact that there's a lot more code in it. And also it's going through the generation one more time. And it's grounded on the data set we fed to the language model and the vector database. All right. All right, so let's tackle on more creative task here. Create a social media post just like what we did before on Terraform code for VPC. Again, being sort of using lots of emojis and try to create that intimacy with users. And then it looks good to me. We still maintain the consistency of the module config. And that looks good to me with some hashtag as well. Write a blog on Terraform code for VPC. Okay, again, tackling on more creative task, letting LLM to generate blog post grounded on the data set we provided. And it is capturing all the information and the steps for us to follow through. And that's it here. I think that gave us good idea of how we can take it. And then let's take a look at some additional details on the slide deck. Let's take a look at the progress in information retrieval. First, search engines we are all familiar with, and we do this every day. Now, if you move on to text generation, prompt goes in to a large language model and the response comes out. Large language models can now generate human-like text for a vast range of topics and styles. There are multiple prompt engineering options available as well, all the way from zero-shot, few-shot prompting, as well as in-context learning to augment LLM's text generation. However, a limitation is that current AI models don't have a grounded understanding of facts. They generate based on detected patterns, basically next word prediction, and sometimes getting too creative. And if you move on to retrieval augmented generation, here language models are combined with context of knowledge and facts, and we can improve on the text generation. In this sample prompt for retrieval augmented generation, we are feeding not only users' question in the prompt, but also the context that we receive from your source of information. You can ingest your own custom data to a vector database with embeddings model, so we can use semantic search based on the meaning of your question, and we can retrieve the relevant chunks from the database and add them to the prompt. Context is all you need for LLM to generate better response. By incorporating external knowledge, the LLM can produce more in-depth, factually consistent, and nuanced text. In our previous companion use case, as you saw in the demo, we have captured usage patterns of the top 7 most downloaded Terraform AWS modules from GitHub repo. That helped our Terraform companion app to produce consistent Terraform code patterns grounded on our dataset. LangChain is an open source framework for building context-aware reasoning applications. In RAG-in-a-Box, we are using LangChain as a composable layer. It provides abstraction and orchestration from protocol all the way to observability. LangChain provides a wide range of integration. Templates provide composable app development using standard templates. LangServe helps developers deploy LangChain runnables and chains as a REST API. LangSmith provides observability. With LangChain Stack, you can streamline your prototype and app development. RAG-in-a-Box refers to a packaged solution that enables retrieval-augmented generation. It runs locally in your VPC, only using open source components, providing full privacy and control without relying on external APIs. As it runs fully locally, the user maintains complete data privacy and system control. It allows for rapid experimentation and prototyping, making state-of-the-art RAG technique more accessible for everyone to explore. Let's take a look at a few LLM options. On top, we have Code Llama 7b model from Meta. We have Zephyr 7b from Hugging Face, and popular Mistral 7b as well. The recent trend has been that the smaller 7b models outperform larger models in specific tasks. With optimization techniques like quantization, we can run 7b models in Amazon EC2 G5 2x large instance. In addition to that, we are running quadrant vector database on a container locally. We are using open source BG embeddings model using sentence transformers from Hugging Face. LangChain provides document loader, retriever components, as well as the remaining orchestration. The entire tech stack runs on a single Amazon EC2 G5 2x large instance. One of the large language models that we can use is Zephyr 7b from Hugging Face, which is fine-tuned from Mistral 7b model from Mistral AI. And despite the compact size, and then compared to larger models, you can see some of the task-based benchmarks, it performs pretty well, especially on the extraction where we can use that specific task for retrieval augmented generation as well. For more details, you can take a look at the model card in the Hugging Face and find out more details from there. In this hands-on demo, I'll show you how to bootstrap Amazon EC2 instance and start testing your choice of LLM as well as RAG components. We'll use Streamlit for a quick end-user interface. We'll also use LangServe to provide REST APIs. Now let's take a look at EC2 instance. Now we have access to Jupyter Lab and how you can bootstrap this here. You can take a look at my blog post that I'm going to share later on. And the prerequisite here is that we've gone through all the dependencies install, and now we want to kickstart the Docker containers. So from the directory, we're going to go ahead and open up a terminal. And based on the quantized model for Zephyr 7b, we will use text generation inference from Hugging Face, and we'll load up the model in container. So it downloaded the weights and going through the sharding process. And then once you see the warm-up model, and then went through that and then default to 0000, now it is connected. Now let's move on to the second terminal. And this time we're gonna launch the quadrant in Docker container. Again, same process. We're gonna run Docker to instantiate quadrant. And these two Docker containers are running locally without relying on external APIs. So your data is 100% local within your VPC. Now, to make sure we can validate, go ahead and open up another terminal. We can run docker ps, and we can confirm that we've got two containers running in our EC2 instance. Now let's open up one of the sample notebook here. I'm gonna go ahead and set up the Langsmith, make sure Docker is running. We just did that. Using the Hugging Face TGI, we can configure the LLM model, do a simple prompting, and we can see the response from the LLM. We can also run streaming as well, and you can see with the simple prompt template, we can get the response streaming to the notebook. We can also test the next question as well, just to make sure the LLM model is responding. Now let's launch the Streamlit app that we prepared. And then we're gonna access the UI. Okay, that's perfect. Now that we have our LLM container and then quadrant running, and we've tested the language model with simple prompting, let's go ahead and launch the LangServe to be able to serve our REST APIs. So again, coming back to Jupyter Labs, open up a terminal. We're going to go to My App directory and then launch the langchain serve command. And that's going to launch our langserve, again, locally running on port 8000. And that's fully running. So that chain.py file ingest the data set that we prepared, and you can see that from quadrant dashboard. So you can see the data imported along with the metadata pointing to the source, and you can see the vector database, the embeddings, length of 1024, along with the page content. And a whole bunch of Terraform code in smaller chunks ingested into quadrant vector database. Now, earlier we launched the Streamlit app, and so you can access the UI from a LLM, as well as the Terraform Companion POC UI is available for us to test. And from a REST API, we also get access to Fast API. You can also invoke multiple API calls here for testing and development as well. And take a look at the invoke method. You can see the details of REST API, and you have also access to streaming method as well. All right, so more details on the schema. And we're taking a look at streaming method as well. All right, so we're gonna open up another browser. Yeah, so we can access to langserve playground. Let's put a simple prompt, Terraform code for VPC. we're gonna see the identical output based on retrieval augmented generation. We can see the VPC module displayed along with additional description. You get access to the intermediate steps where you can see what chunk of text that we retrieved along with the intermediate steps. So you can trace the details of how the retrieval augmented generation is responding based on your input. You can also share the prompt or test that you just performed. Let's try another test. So Terraform code for EKS. Again, in a playground, give us access to simple test, as well as the, again, intermediate steps that will give us better insights on either troubleshoot or having more visibility. Again, going through the text generation, rather lengthy response, but nonetheless gives you the full context. And then, going back, we can also try one more test, Terraform code for S3 bucket. Okay, so let's validate our data set. So the data set that I prepared, just to give you a proof of concept, so we can steer the model to produce consistent output. So I'm using the top 7 most downloaded modules, and I use the usage section from each module, in this case VPC. We want to ground the LLM model to produce consistent modules, and that's captured in this markdown file. So you can see 7 files representing each services. RDS, for example, has sample usage as well. So we are feeding this to vector database, in this case Quadrant. We took a look at each page content as well. The embeddings model we are using has a dimension of 1024, so it can handle quite a complexity, sort of higher dimensional insights from a semantic search. So when you run the length serve, it includes the ingestion mechanism as well. So ingested these files. So when we go ahead and generate, either from Playground or in our Streamlit UI, we can see the effect of retrieval augmented generation. So hope that helps. I can also share more details about the Streamlit app, and then all the rest of it should be available in the blog post. Another benefit of using LangServe is to be able to access remote runnable from your client. So by having 2 lines of code, you can access your LangChain chain service from your client. So it keeps really clean code base for your client, and you can go ahead and consume and invoke runnable.stream to be able to consume the streaming service from your LangChain runnable. My Medium blog posts provide more details on Terraform Companion proof of concept and RAG in a box running on Amazon EC2 using open source. You can scan the QR codes and get access to 2-part series blog posts. 3 tips for steering LLMs using prompt engineering. Number 1, clearly specify the task. Be very explicit about the kind of text you want the model to generate. Provide clear instructions stating the precise task, style, and length requirements. The more specific your prompting, the better the results. Number 2, use examples. Illustrate what you are looking for by providing 1 or 2 examples of the desired output. This gives the model a template to follow and improves its understanding of the task. Examples enable intuitive prompting. Number 3, iterate on prompts. Treat prompt engineering as an iterative process. If the initial outputs are not what you wanted, tweak the prompts systematically. After the wording, add or remove constraints, provide additional examples. Continuously refine the information fed to the model until the outputs match your intent. When bringing large language models into real-world applications, there are some important things that we need to think about. One key challenge is to make sure the model gives helpful, accurate responses, and we want to avoid situations where it might make up information or retrieve things that aren't really relevant. By adopting evaluation-driven deployment and working together on solutions for issues like these, we can find ways to responsibly apply these powerful technologies. Let's talk about the next steps and where we go from here. We want to take a look at experimenting with various data sources. Your data is your crown jewel, and we want to bring the models to the data and not the other way around. So let's make sure we can experiment with various types of data and make sure that LLM responds and delivers a quality response. We also take a look at evaluate the re-rank models to improve the retrieval mechanism. We'll also take a look at LLM and embeddings model fine-tuning to improve on the quality. We can also take a look at increasingly popular multimodal language models that has vision and other capabilities that expands the overall horizon for generative AI. Combining human expertise with the capabilities of generative AI will unlock new innovation that solves real problems. I welcome your thoughts and perspectives. Let's share how we can integrate specialized knowledge with generative models to drive real progress and innovation. All right, that's all I have. I hope that this talk was useful and inspiring. Let's experiment together. Thank you.
All right. Well, thank you so much, David. That was an incredibly cool and informative talk and definitely a super useful application of generative AI. Friendly reminder to folks to please post those questions on the YouTube chat. Do not be shy and share your thoughts and comments. And also, we've just posted David's contact info, so please feel free to connect with him. It's posted on YouTube. And now we've got our final speaker of the day and of the conference. It is Olivier Bierler, a senior software engineer at Elastic, with the talk Toward a Carbon-Aware Cloud. Now, this talk reminds us of the often overlooked impact of our work on CO2 emissions, focusing on the environmental consequences of cloud infrastructure, and it addresses the pressing need for cloud infrastructure teams to make informed carbon-aware choices and gives us some practical methods for measuring and reducing carbon footprints. So let's get to it.
Software engineer in the releasing team, but I'm currently taking a break to work at Carbonifer. Carbonifer is a platform to measure and reduce the carbon footprint of the cloud. Here is a sentence I hear quite often. I have all my infrastructure running in the cloud, so I do not emit CO2. Yes, everything you put in the cloud disappears. It's all magic. But as you know, the cloud is powered by data centers, and data centers use electricity. But electricity is clean, right? No, not really. Let's look at some figure. We think that data centers are responsible of 20 to 25% of the electricity used by the whole digital sector. It's around 1.3% of the total electricity used worldwide. And if we look at some projections, it's showing that 20% of the electricity demand by 2030 is going to be for ICT, 20%. And the cloud is going to take a third of that. Now, if we look at the greenhouse gas emissions, we consider that the cloud is emitting a bit more than the countries like UK or France, around 300 megatons of CO2 per year. And congratulations, we currently overthrown the civil aviation. Data centers are now emitting more CO2 than the civil aviation, and it could climb to 8% by 2030. 8% is huge. It's concerning as human being, but what about as a company? As a company, we need to face regulations and compliance, and some are going to enforce soon. As a company, we want to attract ESG funds. ESG funds are keen to spend money and to fund companies that are showing sustainability. Having a nice carbon footprint could be a great tool for recruitment and staff retention. A study has shown that staff are more keen to join a company which are showing some ethics and some sustainability. It's also a good tool for customer retention, and obviously that could lead to some cost reduction. So what are we responsible of? If we take the basis, basically everybody is understanding that as a company we are responsible of basically the fuel we are burning directly. But what about the Spotify consumption? Yeah. If you, as a developer, need to focus using Spotify or any music streaming system, the carbon emissions of these audio streaming are there accountable in the scope of your carbon footprint of your company? Yeah, I mean, if you need it, it should be accounted. So where should we stop? Here is a report from Mozilla in 2019. They've shown that 98% of their carbon footprint is the use of their product, basically the user using Firefox. So the JGIC protocol came with 3 different scopes. First scope is direct emissions, basically the fuel you are burning. Scope 2 is indirect emissions related to purchase of energy, basically your electricity bill. And the scope 3 is other indirect emissions, also called value chain emissions. For example, business travel, raw material purchase, and even the cloud service purchased. So basically, if you are running a private cloud, the electricity bill is going to be accounted in scope 2, and the purchase of servers is going to be accounted in scope 3. If you are running a public cloud, that means that all electricity is going to be accounted in scope 3. So basically the key here is to understand where to, it's going to be to define the scope of the scope 3. So we have some regulation. In Europe, there is the CSRD, stands for Corporate and Sustainability Reporting Directive. It's going to be enforced in 2024 for large companies and in 2 years for listed SMEs. It's going to be encompassing scope 1 and 2 and even scope 3. SFDR stands for Sustainability Financial Disclosure Regulation. It's more for financing companies, funds and investors, and they will need to account as their scope 3 the carbon footprint of the company they are investing money in. And in US, you also have the SEC Climate Disclosure Rule, which basically it's a little bit the same as SSRD, and it's going to be for scope 1 and 2 and even scope 3 as optional. So there is some terms you hear quite often. First is the CO2 offset, basically compensating and removal. So what is compensation? Compensation is basically planting trees and removal is direct air capture, removing CO2 from the atmosphere. Elimination, on the contrary, is focusing on not emitting CO2, basically removing the source of CO2. So if a company is claiming to be carbon neutral, that means they are focusing on offset, not necessarily on emission. They can keep the same emission as usual, but they're gonna offset it, basically planting trees to offset that. If they are claiming that they're gonna be net zero, that means they're gonna focus on elimination. From my point of view, it's a bit more interesting. And obviously, there is a little bit of a CO2 that they will not be able to eliminate, so that they're going to offset the rest. If you hear about 100% renewable, you need to be careful if it's power bind or match bind. Power bind means you are sure, 100% sure, that the electron powering your data center is coming from a renewable energy source. With match bind, that means, for example, if you have solar panels on the roof of the company and it's powering your data center, is pouring twice your data center, which means you have a lot of electricity produced during the day, and you are selling the excess on the market. But during the night, you need to buy electricity from the market. So you might have covered your whole electricity consumption, but still you need to buy electricity on the market, and this electricity could come from the nearest coal power plant. So now, how to measure your cloud infrastructure? How a data center is working. So basically, the electricity is produced by various sources. For example, coal plants and nuclear plants. Side note, nuclear here is considered as clean energy, as is doesn't emitting any CO2. Or it can come from renewable energy and even hydroelectricity. Everything is transiting over the electricity grid, the regional grid, and it's powering your data center. So if you have a cloud infrastructure, that means that you're gonna have some virtual machine, some containers, some process hosted on bits of those servers in the data center. So as a large majority of the electricity is gonna power these servers, a little bit of electricity is used for powering the computers of the office building, the heaters, the air conditioning, etc., etc. But the large majority is going to be for the servers. So basically, if you have some VMs running on public data centers, that means you could be responsible of a ratio of this electricity coming into the data center. The Green Software Foundation came up with this formula. It has been integrated in ISO, and this formula is the SCI. It stands for Software Carbon Intensity. So basically, it's how we can calculate the carbon intensity of a piece of software by multiplying the energy consumed by the software with the carbon intensity of the grid plus the embodied emission of your hardware. So let's look at the hardware first. So basically, if you have bought a server and this server required 4,000 kilograms of CO2 for being manufactured and being disposed, that means that virtually every year you're gonna emit 1 ton of CO2. So you can even calculate the ratio per hour, per process, etc., etc. So those are called embodied emissions. The use emission, so the E multiplied by the I, is the the carbon emissions of your actual software, regardless on the hardware. So how we calculate that? First, we need to know how many kilowatt hour is used by a software. So if you are running on AWS M4 large instance with 2 CPUs and 8 GB of RAM, and your process is using 50% of that, that means that there is some calculation to do that. You will need 10 watt hour to run that. So we multiply that by the power usage effectiveness. So remember, you have a little bit of loss of electricity when powering a data center. So for example, in AWS Island, we consider that the PUE is 1.2, which means that if you want to have 1.2 kilowatt hour to power your server, you might need to have 1.2 kilowatt hour. So 1.2 kilowatt hour in order to have 1 kilowatt hour. And you multiply all of that by the carbon intensity of the grid. So basically, each regional grid of the world have different energy mix, different ways of producing electricity. So in this example in Ireland, the yearly average is 316 grams of CO2 per kilowatt hour. So each kilowatt hour is gonna emit 300 grams of CO2. So at the end, if you multiply all that, this piece of software will emit 3.8 grams of CO2 per hour. We are talking here in gram of CO2 equivalent because it's not only CO2 which could be emitted while generating electricity. For example, you also could have some methane. Methane is 84 times more potent as greenhouse gas than the CO2. So in order to ease calculation, we are talking about CO2 equivalent and grams of CO2 equivalent. So if we circle back to this SCI formula, if we add the use of the energy used by your software to the embodied emission, it comes to 5 grams of CO2 equivalent per hour. So what are the easily available data? So the average carbon intensity of regional grids are pretty well known. All data centers are producing those figures. And you can also go to apps.electricitymaps.com, where you have this beautiful map and you can see in real time what is the carbon intensity of local grids. For example, here in March 2022, in France, kilowatt hour required 157 grams of CO2 when this kilowatt hour has been produced, while in US it was more than 250 grams of CO2 per kilowatt hour. The power usage effectiveness, those are pretty well-known numbers, and most of cloud providers have those numbers under 1.5. There are less available data. For example, if you want to have accurate measurement of the kilowatts needed by your hardware, you need to know the CPU and the CPU manufacturer, the model, the percentage of usage, etc., etc. Those if you're running something on AWS, or GCP or Azure, it's pretty hard to find this information. How you can know what is the manufacturer of the CPU or the GPU. So in order to ease that, we can use some estimation and coefficient, and most of the time they are good enough for making some relative comparisons. Same thing for memory, storage, and network. Same thing for the embodied emission of hardware. You need to know what type of hardware you are running on, where the server has been manufactured. So in order to ease that, we have some data sets available. And of course, same thing, you can use estimation and coefficient. Another thing which is quite hard to know is the weather prediction. So basically, the energy mix could rely on the weather, for example, if it's coming from the windmills or solar panels. And in 2 days, the prediction are pretty accurate, but in 2 months, it's pretty much unknown. So in order to ease doing that, most of the cloud provider came up with these carbon footprint dashboards and tools. So with one click, you will be able to see what is the carbon footprint of your entire infrastructure. So the granularity is pretty high. You will have those numbers per month, for example, and you need to wait a couple of months to have this data available. If you want to have a finer granularity, you can use a tool named Cloud Carbon Footprint. So basically, it's an open source tool, and it's reading the bills from AWS, GCP, Azure, you name it. So in those bills, you have what type of instance you have used, for how many hours, for how long, etc., etc. Same thing for Lambda, for serverless service, etc., etc. And they will calculate the carbon emissions for you. And you will be able to use this data in a beautiful dashboard as displayed here. If you want to be a little bit more accurate and have very, very fine granularity, you can use Scaphandr. So Scaphandr is, again, an open source tool, and it's basically monitoring the power used by the CPU by using some, basically, probes. So it's not calculating CO2 directly, but at least you have the kilowatt hour used by your CPU, and you can calculate the ratio per process, per container, per whatever you want. So it's not really working well for cloud directly. So it's more if you're running that directly on the server. You also have some APIs. For example, Climatic is a commercial API with a free tier where you can query what is the carbon footprint of a server, for example, M4 large instance on AWS running for 24 hours. So that will give you this number, and that will even give you the embodied emission for that. And you can even use that for different area, for example, freight or whatever you want. There is a lot of data sources. There is also this open source project named Boa Vista. So their flagship project is an API where you will be able to query basically same thing as a Climatic, like I have this type of instances running on Azure for how long, and it's going to calculate the use emissions and the embodied emission. Be careful for the embodying / manufacturing emissions is the emission for the whole lifespan of the project, not per unit of time. There is a lot of new projects that are coming at Boa Vista, so I encourage you to check that. Here is one of their tool in UI form. So basically the same thing, you click on the cloud provider and the cloud instance type, and it's gonna make all the calculations for you, and even the abiotic depletion potential, which is another concerning things we need to have look at. And now my little project. So in this project I have already a small command line tool which is able to estimate Terraform project. So it's an open source tool. You are free to have a look at that and create PRs or whatever you want. So basically it's look at Terraform project, and in Terraform project, as you probably know, we are basically defining what is our infrastructure, what we want in our infrastructure. So in this example, in Europe West 9, which is the French zone in GCP, we want to have one E2 standard 2 instance. And that's going to calculate for you what are going to be the emissions of this project. So let's make a quick demo here. So if we run, so it's running basically the same way we are running Terraform. So if we are running Terraform plan, we can use Carbonifer plan. And in this report, you see that if we want to have 10 instances of M4 X large in Europe Central 1, which is Frankfurt region, it's going to emit 600 kilograms of CO2 equivalent per year. 600 grams is interesting because it's almost a flight from Paris to New York. If we are changing the region, for example, Europe West 3, which is the Paris region, and in France, most of the electricity is produced by nuclear power and hydroelectricity, so the carbon intensity is way lower. So in this example, it's not anymore 600 kilograms of CO2 per hour, but a bit less than 100. So magically, we have divided the carbon emission by 10 by just migrating to another region. So by using this tool, which is called Carbonifer, you can have an estimation of the carbon emission of your Terraform project. So it comes with a little bit of some limitations. For example, everything which is auto scale or which is serverless for now, it's a little bit hard to estimate, but this tool is already covering EC2 and compute instance on AWS, GCP, even RDS instances, and even auto scaling groups, with some assumption, of course, and GCK on Google platform. Let's go back to the presentation. So I also encourage you to check this Green Software Foundation page, where you have the list, an awesome list of all the green software tools you can use to do that. So now we know how to measure it, how we can reduce it. First thing which is obvious is to optimize your software, your code, and use some green coding on software eco-design good practice. It's obvious, but most of the time, if you want to double the power of a software, you would double the size of the server it's running on. And most of the time it's working twice as fast. But first, if you want to minimize the use of resources, which is minimizing the generation of CO2, you might need to optimize your code. Another good thing is choosing the right instance. If you are in the cloud, it's sometimes useless to overcommit to use super big instances, and maybe use the last generation instance. For example, Gravitron instance are way more efficient than other instances on AWS and are using less electricity. I think ARM CPU are using less than 1 kilowatt hour, while legacy CPUs are over 5. And you might want to migrate to hyperscaler or public cloud. All those hyperscalers and public clouds are committed to be net zero by 2030, and even Microsoft Azure want to be carbon negative by 2030. And that's also interesting to look at some alternative cloud providers such as Denver. Denver is a data center in France, and it's going to be a floating data center, naturally cooled down by the stream. And all those hyperscalers are working on improving PUE, the hardware lifespan, and they are more and more buying renewable energy. So basically, on premises, you are keen to you might want to have much more servers than on the cloud, and much more on the used server, and on the cloud you're gonna have fewer highly used server. Be careful on the rebound effect, because you're gonna save a lot of CO2, therefore you might want to add more and more servers. Another good practice is to use the FinOps good practice. So for example, if you want to reduce the cost, you might want to schedule your instances to shut down during the night, or even to use some auto-scaling groups, which are groups of machines self-adjusting depending on the traffic. So basically, the more traffic you have, the more instances, and the less traffic you have, the less instances you will have. So in that case, you will save money, of course, but also you will save CO2, because you will use less resources. So as already mentioned, a good thing is to pick the right region. If we are looking at those numbers coming from the Google platform, in Paris, it's always the best choice on average. And finally, if you want to be a little bit fancier, you might want to be carbon aware. So carbon awareness is the ability of a cloud infrastructure to self-adjust by looking at the carbon intensity of the grid and the carbon emission of itself. So one first concept is temporal shifting. Temporal shifting is basically scheduling an asynchronous task when the electricity is going to be less carbon intensive. For example, if you are doing image or video processing, or AI training, machine learning, DB indexing, etc., etc., you are not forced to do it right now. Most of the time, you can wait a little bit for the electricity to be less carbon intensive. At Google, they already tried that for their own needs with some asynchronous tasks, and they are running those asynchronous tasks when the electricity is less carbon intensive. Another thing is demand shaping. So basically, demand shaping is doing more when the electricity is less carbon intensive. For example, if the electricity is emitting very little CO2, you can be very high resolution video, and you can lower your video, the quality of the video, when the electricity is very carbon intensive. Another good use case is CR servers. For example, you have some workers linked to this CR server, and you put less workers when electricity is very carbon intensive, which means that you're gonna wait a little bit for your PR to be built. but on the other hand, it's going to emit less CO2. And finally, you can choose spatial shifting. So basically, spatial shifting is to leverage all those differences of carbon intensity and energy mix in the world. So in Hot Carbon 23 conference, there is a paper which has been released during this conference, and they are showing that basically they have two different data centers in two different regions with a load balancer. The load balancer usually pick the one which is the closest to the user, and with to minimize the latency. And with this load balancer, they choose to not pick the closest one necessarily, but to pick the one with the least carbon intensity at that moment. And by doing so, they manage to reduce the carbon emission of this infrastructure by 21% with no latency, and to 51% with an acceptable latency. So here is my quick demo. So in this demo, I will have 3 different auto-scaling groups and on different regions and with a global load balancer. So basically, a request coming from a user is going to be picked by the global load balancer, and the global load balancer is going to choose the region on a round-robin mode. And and I will add a carbon-aware scaler which is going to basically reduce the region which are emitting the most and keep the region which is the best. In this example, Ireland is the best, so it's going to shut down all instances in other regions. So let's look at that. So here is the endpoint of the global load balancer, and here is what one of the instance is responding. So this instance just respond, okay, here, hi, I'm from Ireland. So basically it knows where it is, and it's gonna reply as so. And the scalar tool knows all the regions and where instances are deployed. So in this example, Europe West 1, which is Ireland, is the best choice in terms of carbon intensity, and it has 2 instances. So let's hack a little bit this API. And now, the scaler think that Europe West 3 is the best choice because it's emitting less per kilowatt hour. So progressively, those instances are going to move from US West 1 to US West 3. And if we hit the load balancer, at the end, we're going to see that only instances in Paris are going to reply instead. So it's still replying in Dublin. And we're going to wait a little bit. So yes, in Paris, now it has the 2 instances. The 2 instances have been moved from Ireland to Paris. And if we check, yeah, now it's replying from France. So yeah. So quick takeaways. So the first thing, if you want to manage better your carbon emission of the cloud, is to collect usage metrics, then estimate the kilowatt hour based on that. Then using the carbon intensity of the grid, you can have the carbon emission of your cloud infrastructure per hour, and then you inject that in some visualization tool, dashboard, etc., to correlate, analyze, plan, etc., and come up with actions to reduce, schedule, resize, etc., according to the carbon intensity of the grid. And even if you can, bring some carbon awareness where your cloud infrastructure is going to be self-aware of its own emission and self-adjusting alongside with the carbon emissions. Thank you very much. Here are some links. Please check the Green Software Foundation website. They have a lot of very good resources. They also have a podcast named Environmental Variable. So you can find my details here. And don't hesitate to contact me if you have any question. Thank you very much.
Yay, thank you so much, Olivier. This was such an informative and timely talk, and I feel like this topic is coming up more and more these days. So I'm sure that everyone's come away with greater awareness and inspiration for action. Friendly reminder to keep those comments and questions coming on YouTube. And I guess this brings us to the close of the event today, doesn't it?
It does, 100%. 2 amazing days, 3 great MCs that I was also here. It's been beautiful. It's been informative. I really like closing out with a talk on sustainability. Remember, as you build sustainable infrastructure, also build sustainability into your teams, and figure out, like how you can make the people in your teams be able to support operations for a long time. I think that's also a very important one. And then, if you're not tired of listening to Adriana here, there's a podcast that we should be listening to. And I want to highlight this one specifically because maybe you should tell the story. It is not my story to tell.
Oh yeah,
Kelsey.
sure. Yes. Yeah, so I was at KubeCon in Chicago last month, and I got in line for a book signing being done by Kelsey Hightower, and I'm like, okay, I'm going to do this. I stood in line, got to the front, and I was wearing a mask, and I had a sticker for my podcast on, and my podcast is called Geeking Out. And so he looks at it, and he's like, what's Geeking Out? I'm like, oh, it's my podcast. He's like, I can come on your podcast. And I'm thinking, what? Like, you just made my year. Okay. Yeah, I didn't even have to ask. It was just, me putting some bling on my mask to make it more fun. And the topic came up, and so Kelsey was on my podcast, and we actually just dropped the episode on Tuesday. So yeah, you can check it out. You can go to bento.me/geeking out, and it has the links for all of the socials for the podcast. And I've got a variety of people who have come on, including Hazel Weekly and Tim Banks and other folks. A lot of talk about open telemetry, and also I've got some HashiTalk. Kelsey talked about Hashi stuff, but also a friend of mine, Louise Alki, who is a developer on Nomad, he also came on the podcast, and it's actually the most popular podcast episode is the one with Louise. So a lot of people are very excited to hear about Nomad, and also he dabbled in instrumenting Nomad with open telemetry, so he shares his adventures there.
Beautiful, lots of great inspiration. Do we get an answer to the JSON versus YAML conundrum?
I think it's about neck and neck, but I liked Kelsey Hightower's answer on JSON versus YAML, because I think he's like, I think he said something to the effect of, JSON is great for coding purposes, but like writing out YAML is a lot more pleasant experience. Like writing out JSON is kind of icky, which is why I actually like HCL, because I feel like it's the love child of JSON and YAML.
In the best possible way. I love
Yes.
that description. It works. Beautiful. Lots of new material to listen to. I think you're currently at 13 episodes.
Yeah, that's right. Yeah, and
Good.
we just closed off the year, so I'll be restarting in January. And my daughter helps me edit the episodes, and she designed the logo. So
Even better.
yeah.
I love it. Worth checking out, bento.me/geekingout. Meanwhile, if you haven't had enough of HashiTalks, of course, we've got a few more coming. The biggest one, HashiTalks 2024, is our 24-hour event, February 15th through 16th. We're starting in EU time zones and then just going around the clock. So there's plenty of stuff to listen to. 48 talks, because that's how 24 works, if you do half-hour talks. Math is amazing like that. With that, y'all have been amazing. Thank you for joining us as chat partners, as viewers, as speakers, all of you. We couldn't do this without you. Great content. and see you at the next one.
See ya.